let's try 1080. Let's try this. Keep changes. Huh? PC3. Are we lucky? We're not lucky. Okay. Multiple displays. Okay. Landscape, scale. Landscape. Let's try this. Keep changes. No. Let's see if any of this does. Oh God, what did I do? Not good. Mirror, join, mirror. Okay. Nothing. How did this work yesterday?
Perfectly.
So you're on PC4?
No, I'm on PC3.
PC4 there.
Let's try PC4. PC4? PC4.
I was using 3 this morning.
It might be my computer. I wouldn't be surprised. So if somebody has a functional one, that would also be okay. Do we have nothing? Is it on PC4? I think this might be they're talking a different language apparently. Let's try what join says. Oh Jesus.
Okay, well it's season 2, so
that's
now
okay.
try to apply in mirror.
I have to, but I think I'll let's try. Nothing.
Wait. Is 4?
Actually, yeah.
Okay. So
Then we just
go back to first principles, check the obvious.
or just use a different laptop. It's no secret. I have PDF versions and something. I can drop them off even on the Zool if it's needed. What do you think?
My laptop's in the other room because I'm unfortunately presenting at the same time as you.
It don't work.
Do I use any microphone or
No, it turns out why you're just right back here.
You come here. This is no go.
Do you want to just try the other 3?
3?
Yeah, no, that would.
I did try it already. I'm fairly certain it's
I can stand here. Is it a good
unless there's
Something that's actually worked for me is just running X-Render, believe it or not, without any arguments, and it's just
which one?
X-Render.
we need those.
What's the X screen something? What do you call that?
X-Render.
X what?
R-A-N-D-R.
R-A-N-D-R.
Okay.
It's probably Fedora, as usual.
It's a fairly generic one.
Good morning.
Let's try to get another one in front.
Stream is on. Also, we're online. Yes. I will soon start.
Slides would be very useful. It's a somewhat visual presentation. At least I imagine it would be useful. I'll move my laptop away unless.
Not mine. I'm not leaving anything. Just his is fine.
Yes.
Mine is not fine.
Okay, but mine doesn't have anything to show.
Neither does mine anymore because it doesn't work.
Okay, but do you need to show stuff?
Yeah, it's preferable.
And
While my storytelling is usually quite good, it's not as good as slideshow show.
so
What's the problem?
do we do?
My computer.
Well,
I
it's
believe.
just got it in
Should I, do you want mine?
Sure.
presentation, so if you share
Can
something,
I,
you can send on yours. You're running off.
Yeah,
Can I?
Okay.
Anybody with
Can I just drop the file here? I got a PDF, so.
Yeah. You able to have some laptop donation?
Upload file, downloads. Does a PDF work? I have a PowerPoint. What kind of laptop? I think it would better go for a PDF.
We're sorting out technical issues and then we will start.
Let's see how this works. Are you on Zulip?
Yes.
It should be on the MariaDB on conference, like when you pop it, stream, whatever you call it. We might have multiple things.
Okay, so you're going 4 now?
But you think you might have just had the wrong one, maybe?
4, right? Okay, 4 button pressed.
No bueno. I believe it's the universal language for non-technical difficulties. Does anyone? Do we know that somebody who has a laptop that actually has one? Max?
Yeah, well,
Max is not good.
mine did yesterday. Well, that was yesterday. And it's 5 years. Patience, which one? 3?
Can
you see what 2 monitors?
I am using this one. Which one is it?
3?
It has a,
Okay,
it has
now
a,
I have something.
yes.
We have nothing here.
Okay, button pushed.
Is there something
Yeah.
that's on? Yeah.
Okay.
Oh.
Slow down, Foster. Hardware's not that quick. Okay. You are on 3?
Sorry, maybe it's a weak signal from laptop. It's
Could be.
amplifier.
Okay.
Let's give it a try. What'll be the first time, I guess?
3.
Mirror?
Wait. It's not.
Yes,
It's not sticky on it.
It detects it, but it's. Are you sure? Is your projector off? I don't think that's gonna be it.
There was those 2 before.
I mean, we might not. We actually might need somebody who knows how this thing works. Or I don't think we qualify for it. Yeah, I think we have major technical difficulties. Major technical difficulties. Hopefully with that one. Hopefully not with all the computers.
I think it's the same symptom that I have in mine. Can you put the force?
Force?
Mirrors? Detects it.
What?
Is it? Let's see what the external only.
Sorry, it wasn't sticky. Press the PC4.
It's not staying.
Let me go back. Well, if nobody else, we have to have like a textbook style. Everybody follows their own local slideshow. If things don't turn out, or we don't even have a whiteboard. We do have paper there, so I can very impromptu do
Let's go back to
and
Yep. Cool.
VGA never fails. I gotta tell you, sometimes technology, sticker will work.
3. Anyone? 3?
Turn it on and off. Have we tried that?
Yeah, we will try that.
Yep. Off. Off. Oof.
I think we might have broken this. The no show button did.
Okay,
Okay.
start again. Yeah,
A
wait.
little bit of time. Patience, patience.
Let's
Power
follow our most usual advice is that just what happens if you just turn it on and off and on again. So.
Okay, it's still pairing.
Hopefully. Diagrams?
Yeah, that's on.
Well, thank you, Google. Kind of don't want.
I think you have to wait that that it stops because they are still ventilating.
Oh, okay. Silly. Oh.
You need to wait a bit.
We broke even more things. Luckily, we're not projector experts. It's not a database, so I think it's okay.
Yeah.
I'll start explaining the background so if you can
This is
sort
gonna
of sit down and sort of relax.
Can I? I can just talk. Oh, I can
Try now.
talk.
Yeah, it's coming. It's coming. It's coming.
Okay. Plug them on the cables. Get ready.
Is this one?
No.
Try with that one first.
Let's give it a see if it.
Okay.
Let's give what's that number 4? Three.
3.
Okay. Do we know how they use this thing?
Yeah.
Okay.
Maybe the no-show button is.
Okay, now it's ready. 3.
Mm-hmm.
Yeah.
No, it's not waiting. No, but the problem is that it's not staying. I need to ask some people from the room.
And probably we just need to start and you have.
I can talk.
Yeah.
It's not a problem. We got a board. I'll draw things.
Yeah.
I'll draw.
Yeah.
I'm not afraid to improvise.
Oh, we could put the URL to it in a pad.
I'll put it on the pad. It's on Zulu, so I'll.
Yeah, so if you
Oh, but I can't put an URL to something that's a PDF. That's on my laptop. It's on Zulu. So.
Oh, yeah. But the Zulip will have a fixed URL.
How does this work?
So the machine.
Sort out the technical issues and we're now have support from higher up, so let's hope that we get that sorted out In the meantime, we will start the first session with an improvised way of communicating the content. So, now turning myself to the audience, welcome to the MariaDB Unconference Week in Finland. We have already started yesterday in a non-broadcast version with an unconference work session day on Tuesday. Today we have two parallel sessions at the MariaDB Unconference. One is a work session, still not broadcast, but now we also have a set of presentations for everybody to enjoy, both here in the audience and for those following on the stream. And tomorrow we will continue with the Serverfest. So a couple of words on what the Unconference is and was and will be about. So in the days prior to the pandemic, the way for MariaDB Foundation to meet was through unconferences, which meant that we traveled somewhere. Usually we had 2 unconferences a year, and they were either in the US, in Europe, or in Asia. And we then stopped having them when the pandemic came, because you couldn't travel and you couldn't meet. So what we did instead was we invented something we called a Serverfest. So the Serverfest was directed at our users, whereas the Unconference is directed at those who develop MariaDB server itself. And now we've revived both the old one and continuing the tradition of the new tradition of MariaDB Serverfest. So the Serverfest directed at the end users of MariaDB, who themselves are, of course, you are developers, will start tomorrow, and today is the broadcast part in parallel with a work session track for the Unconference. My name is Kai Arne, I'm the CEO of MariaDB Foundation, and I will now say a couple of words about today's schedule and then hand over to the poor Markus Mäkelä, who will start off the first presentation without having many slides to show you in the public. That is a session about the MariaDB network protocol, both its history and its current state, and looking ahead as to whether it will change or not. Then we have Federico Razzoli on stored procedures and why they should be improved. And again, this is a highly technical session, so for an audience who really know what that is about. Then we have Roman Nozdrin on how we vectorized an engine that wasn't supposed to be vectorized. We have a coffee break, and we hope you will too. And then Christian Nielsen of replication fame will talk about dirty secrets in a kind of a Ask Me Anything session on MariaDB replication. Then we have an overview of how to contribute to MariaDB, or how it has been contributed to by our Chief Contribution Officer, Andrew Hutchings. After lunch, we again have Christian Nielsen speeding up Slave Connect, Binlog GTIT indices, a particular MDev with quite a lot of detail. Then it's Andrei Yelkin and Brandon Nesterenko on XA transaction replication and performance improvements on the parallel slaves. Jia Yu Zhou about heap versus temp table, brief analysis of internal temporary table is the last one before the afternoon coffee break. And then we have 3 more sessions today. Alexander Barkov, improving consistency and performance and compatibility and ease of use. Trevor Gross, easier plugin design with Rust. Clevis in MariaDB. And then Daniel Lenski of Amazon about improving the security and usability of TLS in MariaDB. So that's today's program, and we are trying in the background to resolve our technical issues so that we will be able to share slides. Before that, I hope you will be giving Markus Mäkelä a not so hard time, because it is hard to improvise how to present without proper slides. So thank you, Markus, for being flexible and talking about the protocol without the usual, shall we say, visual protocol.
I'm up for the challenge. So. Thank you very much. Can you hear me in the back? Can you hear me in the back better? Which one do you prefer?
Microphone.
Microphone. I'll go with that. So, hello everybody. Do we have visual aids?
If we go to this URL, there is a link to the PDF there if anyone
Perfect.
wants to follow.
Perfect.
on that.
I don't know if that's going to help, because I don't know if I'm going to be able to follow exactly on that, but I'll try and keep it going. Okay, so hello everybody. I'm Markus Mäkelä, senior software engineer working at MariaDB PLC on the MaxScale project. What this talk is the client-server protocol. So you have your client and you have your server, and the thing they use to communicate with each other, be it over TCP, Unix domain sockets, name pipes, whatever that might be. The history is longer than we have time for, so for the sake of not covering ancient history, which is irrelevant nowadays, I'll start from saying that the, in quotes, modern history starts from MySQL 4.1, which is where, to my knowledge, was the latest revamp of the protocol, but that's ancient by nowadays standards, so we start from MariaDB 5.5 and MySQL 5.5, at which point they were both still very, very much similar. I'm not going to talk about the X protocol, because, okay, how many knows the X protocol? Give a show of hands. Nobody. Well, okay, so it's a second style of protocol that isn't really relevant for this talk, since the history is not shared by MariaDB. MariaDB doesn't implement it as far as I know, and so we exclude that. Also, we exclude all the kind of special kind of protocols like handler, socket, and everything. So we focus on just the plain basic network protocol. And I planned on having a very visual overview of what what the overview of the protocol is, but let's just keep it simple. There's a client, there's a server, they exchange messages. Each message is wrapped in a packet, has a 4-byte header. There's a compressed protocol which wraps the normal protocol, which has a 7-byte header. It's much better with the visual parts. The connection starts by the server sending a hello packet, to which the client responds with a hello response packet, called handshake packet and handshake response packet. They contain various bits of authentication information, capabilities and such, which define how the protocol actually works. If the server is happy with the client's response, it says, okay, you can come in. If it's not, it asks it to authenticate again or just rejects it immediately. Then after that initial handshake dance, it goes into the command phase, which is where the actual useful work is being done. I define it in two different categories. There's the text protocol as well as the binary protocol. The text protocol is simple. You send a plain text SQL query and the server gives you a response. The binary version is a two-phase style of communicating, where you first prepare something and then you later execute it. This might or might not be visible in the driver you're using, but in practice these are two different ways of communicating with the server. Do you have questions?
Yeah. Are all these
Please hold your technical questions until later. If something's on fire, you can say it, but
are all these specs on the knowledge base? Because it seems like you pulled them from there.
yes. If they're not, I haven't documented them well enough. I've had an effort of doing that. Anyways, this is all information pulled from the MariaDB knowledge base, the MySQL documentation, which sometimes is not correct, and various bits of articles, history, git log, everything. So I haven't developed this myself, but this is my archaeology, so to say.
there's a third kind of, there's many commands, of which the two useful ones are the comp query, sends a text query, you get the result, comp statement prepares a statement, the server says, okay, you can run this now with this ID, execute, comp statement execute is used to execute it. There's a comp change user when you want to do a re-authentication in the middle of a connection, mostly for connection pooling stuff. Keep that in mind, there's a reference to this later on. So the server, of course, has to respond with something. So what does it respond with? If I say select something, it gives me a result set. If I say do this, it says okay, or it says an error, or it says something. In practice, oh, this would be very good with some visuals, but on the server response packets slide, if you happen to see that, there's the details and all the extensions included as well. But the basic idea of an OK packet is that it contains information such as the auto-generated insert ID, how many rows were affected, and other bits of things like warnings and such. Errors have error code, the SQL state, and the human readable message. The most interesting result is a result set. It's a stream of packets, and this is actually how you get the rows from the server. The result set consists of a single packet telling you how wide the result is, or how many columns it has. After this packet, called the column count packet, there's the column definition packets, which is metadata for each of the columns, so name, table, database, data type, decimals, and such. Oh, perfect. This is going to be much better. So we have, next slide, please. So we have the result set, which has the column count packet at the top, metadata, and after the metadata, there's a bunch of them. There's an EOF packet. Those are just the limiting packets, but they do contain a little bit of information, such as the warning count and server status. After which comes a stream of result set rows, which for the text protocol are literally just text fields prefixed with length. And for the binary protocol, it's literal binary data, little endian integers, strings, and such. The definitions are various. For example, date times have their own type.
Just use left right here. And then
Let's see what this is. This is what it looks like. This is essentially me doing select one on my laptop. There's some extensions to it, so it might look bigger than needed, but that's what it looks like at a network dump. So what's shared by MariaDB and MySQL, and I'm just going to ignore all the stuff from 5.1 to 5.5, plugin authentication and such, pretty much, and go straight into things that are of minor relevance nowadays. So we have the length of encoded passwords, not very interesting. There used to be a limit, 126 bytes, so you could have a long password. That was in MariaDB 10 and 5.6. It's kind of a, when you think about it, having longer passwords, well, to be honest, it's not just authentication or passwords. All authentication data could be, I don't know, you send a picture of your face or something. But in general, this was an old extension. There's one, the bits here refer to the capabilities in the handshake. There's 32 bits that are shared, and we'll go with the extensions later on. One of the bit 23, I believe, is expired passwords. This just indicates that the client is capable of changing their password. And then the reset connection, which is just clears the state of the session. This does not have a capability bit, but this is a command that was added to the protocol in MariaDB 10.2 and MySQL 5.7. Very useful for connection pooling, much faster than doing a re-authentication if all you want to do is reset your user variables and drop all temp tables. Are we on the right slide almost? So I think this is we're starting to get into more interesting shared capabilities or extensions to the protocol, which is connection attributes, arbitrary metadata, key value, is visible in the performance schema tables, and most connectors set them to something useful. The command line client says that, okay, I'm a MariaDB client. PyMySQL, for example, sets it to something. Python connector sets it to something. So everything sets it to something. Somewhat useful from somebody trying to figure out, okay, which application is this? If you share it, if you don't know which username maps to what. So this is extremely useful for mainly debugging. Down here you can see, for example, this is what I use with the command line. I'm coming from a Linux. I connected to that host and such. PID, for example, is very useful if I have multiple processes and one of them does something. They're all coming from the same host, so this is extremely useful information for debugging stuff. And this is another kind of metadata extension, session tracking. This is kind of an extendable format that is appended to the OK packets. So when I do an insert or I set a variable, the server tags in extra data telling that something changed. It could be a configuration variable. The default database might have changed, the transaction state might have changed, or characteristics of the transaction might have changed. This is mostly, I'd say, for the drivers, not so much for the applications, I'd say, at least from my experience. This is extremely useful when you just kind of want to pick out a couple of pieces of information that's otherwise hard to get if you're kind of in a middleware situation that was not expressed previously by the older protocol bits of information. And then we have something that some people love and some people hate, the deprecate EOF protocol, which is, I believe, an invention of MySQL. They decided that the EOF packet is not good enough, which to some extent is not, and they replaced them with OK packets. But they still kept the visual look of an EOF packet, so it's very confusing now. Which, well, once you know what to expect, you'll be able to deal with it. It just removes what at the time was called a redundant EOF packet, because we had in our results set, if we remember, we have how many columns we have the column metadata, then we have a delimiting packet. We can just count the metadata packet to skip the EOF packet, and we remove some data. Unfortunately, it did contain the server status warnings, which turned out to be an actual bug. There's an open pull request for putting that back in. And in some cases, if I remember correctly, stored procedures or cursors, one of the two, you can't use this essentially. The reason why this was done, to my knowledge, is that you will be able to get, in a result set, you'll be able to add the previously mentioned metadata. So you do a select, and you'll be able to know if the transaction state changed. You'll do a select, and you know if something somewhere caused something else to change. So this is a useful extension, but the protocol itself has, people have differing opinions of this. Has resulted in my personal favorite bugs of you just getting not what you expect. You ask for this and you get the other thing. MySQL 5.7, if you use this with the query cache, don't use the query cache with 5.7 and mixed clients because it'll just give you garbage, essentially. MariaDB fixed this in 10.2.8. The problem was you had a query cache, you had results from clients that did not use the deprecate EOF protocol, and you had results from clients that did use the deprecate EOF protocol, and they just got mixed up, unfortunately.
That actually was something that was found on one of the communication channels, and I really spent one day debugging what's on earth going on, because sometimes it works.
It's very confusing. It's very confusing. Anyways, let's move on to things that are only in MySQL. I'll start with these because we need to reference these later on in the MariaDB extensions. So we have the optional results and metadata. As you remember, I mentioned the column definition packets. They are technically not needed if you know what you're getting. If you know you're getting a text string from this table and this column, why do you need the column definition packets? They're big. I believe we could go, well, let's not go back. And they are a large chunk of the data sent by the server. It's just metadata. And if you know what it is, you can just skip that. So MySQL implemented that by just optionally removing the whole definitions and just indicating that, okay, you're not going to get metadata, you'll get the result rows immediately. they implemented it by with capability flag, and the client must set results and metadata to none. So this is very, you must opt in very heavily for this to work. It's in MySQL 8. MariaDB shares a similar implementation, identical on the network level, but the behavior is different. Well, more on that later.
Actually,
Can you hold on to questions until later? We're a bit tight on the schedule. We'll come back to this in the MariaDB part. And then some critical minor ZSD decompression for the compressed protocol, which unfortunately was missed with the visual part. By default, it uses the zlib compression, if I remember correctly. And this is just changing the algorithm. It does add one extra byte to the end of the handshake packet, indicating the compression level of that they desire to use. Then there's something called multi-factor authentication, which is essentially an authentication switch request sent by the server after successful authentication. So the idea, I believe, is to be able to authenticate using multiple mechanisms. So for example, you first want to have a password authentication, and then after you go with the PAM authentication, and then whatever. So the idea is that you have multiple loops of authentication, which I would say would be doable with alt switch request. And they invented a whole new packet for that. That is literally identical to the alt switch request, except it's a different command. So, this seems useful, but I don't know of any practical uses. I'm not very involved in this part. Another interesting thing is that MySQL has reserved bit number 30 for extending the capabilities. It's 4 bytes, and all the bits in those 4 bytes have been used in MySQL at this point, I believe, excluding any old kind of like deprecated functionality and such. MySQL, to my knowledge, has not yet taken this into use, so they are still stuck with a 4-byte capability for the foreseeable future. And then there's an interesting one. This is my personal favorite, I think. Query attributes. I mentioned this yesterday for those who are here. It is mysterious to me. They decided to add essentially the equivalent of the binary protocol to COM query, which I think this is a great example of visual presentations. Here you have the extended COM query, and here you have the MariaDB version. It's quite simple, I would say. And the intention of this is kind of, I asked around, the question was like, well, what do you use this for? And I think the MySQL documentation mentions that the use case is for tracing web applications to be able to know which request is done by which client, which web page, and so on. So essentially, query level user variables, sort of. And this is only accessible with the SQL function MySQL query attribute string. It's always a string. It's nothing else. It's essentially asking a user variable that always is a string. I believe it returns a null if it's not. If you ask it twice in a statement and you don't set them again, it'll give you null. So it's essentially a set statement for user variables, which is I asked if that's possible. Not currently, but it could be extremely simple to emulate. This is kind of this is a feature looking for a use case, in my personal opinion, which is, well, I might be wrong. But the fact is that it adds a very complex, at least on the protocol level, extension for something that's essentially doable on the SQL level. Let's keep going into the things that are only in our MariaDB, or the MariaDB extensions, as I'd say. So we have to start off by saying that MariaDB extended the capabilities a long time ago. MariaDB took into use the extra 4 bytes from filler space of 23 bytes, which was previously unused, both on the client and the server. This was done in MariaDB 10.2. This extended it to an 8-byte capability, and as of 10.6, there are 28 unused bits. And Of those bits, I believe there are 3 that are currently in use, which are MariaDB client statement bulk operations. It adds support for a specific command that was not previously sent. It's instead of a com statement execute, you have a com statement bulk execute. So it is essentially just saying, I prepared a statement, please execute it 100 times with these 100 parameters. It is the fastest way to load data into MariaDB that I know of. Faster than load data local length file, faster than anything, essentially, unless you literally have the data on disk and import tablespace or something. Very fast. C connector, the MariaDB C connector, ODBC connector, Java connector, Node.js connector, I believe, and R2DBC connector all use this, as far as I know, for bulk loading of data. Extremely fast. Added in MariaDB 10.2. In the same release, there was the execute immediate, which is not really a capability flag, indicated by capability flag, but it extends the meaning of the prepared statement protocol to the binary protocol, where you can refer in an execution of a statement to the previous preparation without knowing the ID. It uses the ID -1 to refer to the previous one. Why would you want to do this? If you could just forget your ID while you prepared and send? No. You want to do it because you want to send the prepare and the execute in the same time without waiting for the server response. This is very good for data streaming or pipelining, where you start sending stuff without waiting for the response. For example, I know the ODBC connector in MariaDB implements execute direct. We're using this. It gives you more information than trying to convert the data into binary text protocol and then emulating it. This is kind of it's just a nice feature of allowing to do things without having to pay for the latency cost of the back and forth from preparing and then executing. And we have the extended metadata. So this is the same thing that MySQL implemented with the optional column definitions, except in my opinion, the MariaDB implementation is actually useful. So the protocol is exactly the same. In the first packet of a result set, meaning the thing that gives you your select result, it indicates 1 byte telling you whether it's going to give you the metadata or not. Except in MariaDB, this is automatic, and it's only sent by com statement execute. This is done because you can refer to a prepared statement by an ID, and if you execute that same thing multiple times, the second time you execute that, you don't need the metadata. So this is what's called a MariaDB client cache metadata. So it's metadata caching instead of optional metadata. So this is more of a driver level implementation, and this is known to be very good for performance. In some somewhat extreme examples, it was the MariaDB JDBC connector has in one of the release notes, as a comparison, it was significantly faster when you had a 1 row select with multiple columns, because if you're doing a select 1, 1, 1, 1, 1, 1, 1, you get essentially a big list of metadata telling you that it's an int, it has the name of this and this and this, it's several hundred bytes, and the actual data you get is like, I don't know, 20 bytes. So this is a very good optimization for performance. I think I got these in the wrong order. I was talking about the second one. The first one is extended metadata. It just extends the metadata sent in results to be 2 bytes. So you're able to express more information. For example, previously in, let's say, MariaDB 10.2, you have a JSON field and you have a long text field. You're not able to distinguish the two on the client side. So you essentially don't know you have JSON when you have JSON. This fixes it by giving you more information than giving you the real type. I think it actually is more of more than just 2 bytes of information. But this just extends the protocol to be able to express what you're getting much better. So this is now we're coming to the experimental part of me trying to figure out how to extend the protocol without actually extending the protocol. And start off by what I'd call the early metadata idea, is that you have the session track system variables, so the thing that previously said that, okay, I did this, and in the OK packet you get the metadata of changes in system variables, the default database, transaction characteristics. So when I'm connecting, why not just send them in the initial OK response to the authentication? Because these are things that the drivers usually, they start off, if anyone has looked at what the driver does, or database driver does, is the first thing it connects, and then it does select characters at time zone, blah, blah, blah. It selects a whole bunch of data that it needs to know how to behave. There's things in, it needs to know the system's configuration before it can act correctly. So just send them in the OK packet without it asking it. This is the very best case estimations of how much this reduces the network traffic. It's about 60% if you have like 100% usage of the information sent by the server. This is, of course, the worst case is that you send extra data that is not used, but then the question is, why do you have that bit enabled that sends it in the first place? So this is kind of, this just optimizes the way of asking or giving the configuration of the server in a compact way. There's another idea that leverages the same session tracking in the OK packet is load statistics. Very useful for connectors, mostly, for example, JDBC connection pools. You open connections to multiple servers in the connection pool. You want to load balance between those servers, and one of the servers just crashes. And then it comes back up again because, I don't know, the power went out or something. And at that point it has no connections, and all the other nodes have a part of those connections. So normally it'll take a slow time to kind of stabilize, but if you know that one of the servers has no connections, you could pool all new connections there. So providing the current number of connected clients, you're able to recover much faster from server failures in a connection pooling situation. And we kind of implemented this outside of the MariaDB server as an extension without extending it, the protocol. So MaxScale 2308 actually sends a set of metadata in the authentication packet. It also emulates a threads connected system variable which does not exist, and sends this information. The connector J 3.2.0 MariaDB uses this information to avoid having to query them, the variables, and also for better recovery in error situations. I opened also an MDev for this, and I believe this is the kind of, the discussion has been that this would be a reasonable thing to implement. If you want system variable tracking, just send it in the initial packet, that way you don't have to, you avoid work with this. It's not implemented yet, but I believe, well, it's open. Then we have something that has very recently had a lot of discussion, is the connection redirection. For those who know the HTTP protocol, it's essentially 301 moved permanently, or 303C other, meaning that you connect to somewhere and it says like, please go there, redirecting. It's the two kind of main use cases are seamless shutdowns of servers. So when you put a server down, it starts advertising that please don't come here, go somewhere else. And that way your clients that are connecting to, still keep connecting to, are seamlessly redirected to somewhere else, the same as a web server. The original idea for this was latency-free load balancing, because when you have something between your database and your client, each node adds latency, and that's usually something you want to avoid. So you could go to a load balancer node that then directs you to the actual node directly. There's two complementary implementations. I initially started with competing implementations, but I'd say they're complementary. So the first one is the original one described in MDev 15935, which I believe is in MariaDB 11.3. This uses the same session tracking mechanism in the OK responses to essentially say like, hey, this is the redirection where you should be going. This is fully voluntarily, and it's kind of technically supported. More on that later. And this way, only drivers that support it are able to see. Only clients that support this session tracking are only able to see. And this in no way affects the existing functionality. But that can sometimes be a problem also, that it doesn't change the existing functionality. So Dan Lansky, which I believe has a talk about as a security later on today, has made a pull request on this with a different approach to this. And it does it by giving a specific error stating that please don't come here, go somewhere else. This is a kind of like a hard stop. Instead of saying like you cannot come here, and then the client getting an error that says you cannot come here, but you could try it here elsewhere. So I believe the traditional method of pulling a server down is reducing max connections, so you get too many connections errors. That way you let the existing connections do their work, and then no new connections take place. This would be a definite improvement on that. First of all, for just human readable things. If you're able to say that this server is going down, but there's a different one there, you might be on a command line client, you'd be able to do that manually. Automatic systems might be able to do that automatically, and this just this is a different approach for solving the same problem. I think they're complementary or complement each other. The problem is that it needs fixes on the security or TLS level for this to be reliable. Because if you connect and you get an error saying that go somewhere else, there's a kind of a man-in-the-middle problem there if you don't finish authentication first. MaxScale technically implements this, and you can technically use it with the C connector, which surprisingly understands the metadata sent in the initial OK packet. MaxScale added support for setting essentially arbitrary key values for metadata in the initial handshake packet. So you could technically prototype this already.
Does that actually work at all? Because it's only under the shutdown itself, which can take a sub-second. Because after that,
that's why there's
you don't get any information.
Essentially, so that's why there's two approaches to it, and it's kind of like a more of a controllable thing. But button. There we go. So, and then there's one verb. This is the last one, and probably the least reasonable way of extending the protocol without extending it is out-of-band warnings, which for things sitting between a client and the server or a GUI application or something, mostly for things sitting between a client and the server. You currently have to execute to show warnings to be able to get your warnings. And if you have multiple queries in progress, for example, a pipeline queries, I think you actually lose your warnings. If you send 5 queries and expect 5 results, and one of them in the middle creates a warning, I think those are lost. So one way of dealing with this, and also doing it in a way which avoids a round trip, is just tagging them on into the responses as, I don't know, something called a warning, for example. This really would benefit from an extension of the session tracking system itself to be able to indicate that this is not a system variable, but this is something else. The reason why you want to do this, in the command line client, you do execute a select, and then it says 2 warnings. And then you're like, okay, what are those? Then you do show warnings, and then you get your result. It would be kind of nice to actually see the warnings without having to ask for them. Sometimes, so this could be kind of a usability improvement. But for most cases, I'd say it's more of a, when you want to intercept a query stream and you want to see the warnings without having to go and inject queries into the stream. The problem is that this could be costly if you don't care about the warnings. You're getting a whole lot of warnings. So
the thing is that I haven't seen any customers actually ever looking at the warnings from in applications. They're basically ignoring all of those.
Essentially.
That's why I actually had extended the SQL error plugin, so you can also say that store all warnings in a log.
Yeah, so there's the kind of the, but we'll keep the discussion. I believe we're quite at the end. I believe. So yes, a summary. So we have, I'd say I call the shared history stops at 5.7 because at that point MySQL went this way. MariaDB looked at MySQL, well said we're going to go a little bit of this way. In some sense, they're not too different on the protocol level. There's not that many extensions. MySQL ran out of bits. MariaDB still has bits, so, and they're not going to conflict unless MySQL literally does the same thing that MariaDB did, and decides to use the exact same bits. I hope they don't, but well, I don't know. But bits are expensive. Once you take it into use, that's it. It's only one chance to use it. So if there's a way to only use the bits when you really need them to, for example, expressing that, okay, the protocol is going to send you something very different, a different type of a response, that would seem like a smart thing, or at least historically has seemed like a smart thing. And there is no fact that the protocol has diverged. You have the MySQL 8 protocol, or 8.1 protocol, and the MariaDB 10.6 protocols. But I believe you can converge those protocols quite easily without like a huge change in work. Although some of those are quite of questionable like use. The query attributes, there's serious use case for those possibly. The column definitions already exist on the protocol level, you just need the SQL functionality. ZSD decompression, it's a good algorithm as far as I know, so that seems like a reasonable thing. As for whether the compressed protocol itself is that useful is another question in and of itself. And in some sense, the multi-factor authentication thing could also seem useful, but I might question the need for a new packet, but still. And I'd say the existing protocol has room for extension, at least the MariaDB one. So I would not be very worried about running out of bits, because we have 28, I believe, if I counted them correctly. One that was taken into use and actually thrown away, the comp statement multi for those in the know. And then there's also, if we run out of bits, we can just abuse the protocol in some sense. Like I've demonstrated by injecting things into the session tracking variables that shouldn't really be there. So I think this is also one way of taking the protocol in a direction where you don't specifically hard code how the protocol behaves or how the information is transmitted with bits of fixed sizes, and you could go with an arbitrary key value system of strings. And I believe this is exactly how, for example, Postgres sends all connection-related metadata. It's just key values of strings, essentially. Also, all kinds of server variables. But I believe that is it. Yes, and thank you for sitting through my presentation. And I don't know if we have any questions.
Yes, you said
We have a lot of questions, but more importantly, do we have time?
not if you start asking if you have time.
Okay, ask your questions. Go ahead.
Go back to the slide when I said this.
Which one it is? Let's go. Say stop.
About 10 slides back.
No.
It was about this MySQL that they can don't send metadata.
I think it's this one. I think.
Yeah, so this one you said that
Yes.
the metadata is you can ignore it if you know the data. You never
Yes.
know the data types.
Unless it's select version comment. Is it ever going to be an integer?
You don't know.
Well, that's. I mean, the thing is that it will. Well, if you.
I can understand that you skip column names. Column names you know in the query.
Yes.
The data types never. So in prepare statement makes sense because after the first one it doesn't change.
Yes, I agree with that.
But I think that's just dangerous.
It is. And for exactly for this reason, this is where MariaDB, to my knowledge, went with just going with the prepared statement protocol, because once you get the information, you cache it on the client side. That's that.
I think that's time that they connect that is a portlet already.
The MariaDB ones, I believe they do all. For example, the JDBC connector leverages not the MySQL implementation, but the MariaDB implementation is very fast.
No, I mean the standard compression.
Standard compression?
That's standard.
A Z standard.
Yeah.
The MariaDB ones.
The connector.
They probably already support it,
Yeah,
but MariaDB does not
The
implement
server
it.
doesn't do it, but connector
Yes.
does.
You had a question.
You asked about use cases. I have one. Let's discuss it after.
I love it.
And,
I might hate it, but we'll see. I hope I love it.
and multi-factor authentication, as you know, we are doing that already with change.
You're already in the works?
Well, we can do alternative and to do, we have a request to do and, but that does the same thing. You don't tell the client that authentication succeeded and
Okay, so we would, there's an existing one, I don't know, I think it's kind of a waste of a command byte, but
Yeah, so I totally agree, we'll do it.
Yeah.
using command.
it's, yes, you had a question, I believe.
Yeah, about redirection, you
Yes.
mentioned that there could be a man-in-the-middle attack problem, right?
Yes.
How do similar technologies solve the problem? Like, for example, Cassandra or some other technology?
Well, I don't know anything about Cassandra, unfortunately, but I think,
Just an example, because it does the same thing. You query one node.
yeah, and it tells you to go somewhere else.
If you
You-
actually have secure connections and you check the server that you connect
Yes.
with, then there's no problem with redirect.
Yes, and this is exactly why I mentioned that the error response implementation depends on, or it's set to depend on. I don't know if it really depends or not. That's up for debate. And if you establish a fully verified TLS connection, there's no problem, essentially.
Just a clarification, so the session tracking and error and putting in the error message, it's not that one is optional and the other one is forceful, because the client can just, client doesn't disconnect after a syntax error, so error doesn't
Yes.
need disconnection, and on the other hand, the server can still forcefully disconnect after the session tracking change, so it's
Yes.
on a different level. They both can be optional, both can be forceful.
Yes, I agree that. I think it's just that if, for as far as I know, all clients that get an OK packet after authentication don't try to read an error packet right after that. So if you get an error packet, it's well, but I think that's mainly for the connection.
If you come in the middle of the session.
Yes, then I think the error would also be functional, but I think then it's up for debate. You want to do that. If you want to, you can do both also. But I think that's kind of like a detail level. I think the high level idea is what I think.
Okay, can we then go back to the one where
Which one?
that's exactly what Sega was talking about, where we
Redirect?
try to do a redirect.
No. Is it this one?
Redirect.
No.
Not this one.
No. This one.
Yeah, so
Here we go.
I don't think this makes any sense at all. If we don't do a server change, and server change means after we do a shutdown, we
Of course we do
basically.
a server change.
Sorry?
Of course there will be some server changes.
I believe there already
No,
is.
I said that it doesn't. Doesn't make any sense if you don't do another server change. Basically, that when we do shutdown, we basically never shut down.
No, that's, so the idea is how can it be used for seamless shutdown is that the tool, for example, MaxScale, sets this redirection thing and all new clients and all existing clients start getting a redirection message. Then MaxScale waits like a few minutes and then MaxScale shuts down the server.
Yeah, but the thing is that do the same thing without MaxScale. We can do that too.
I mean, this is, I think the
No,
main
only
use
MaxScale,
case.
I mean,
No, not Max. Don't think about MaxScale. Think about the DBA. What they want to do is, I want to pull down the server.
Right,
I have 5,000 connections on it. I know they're going to be there for 5 seconds each connection. So I say, okay, new ones go there. Old ones, you finish your work. And once it drains all the connections, you pull the plug on it. So that's, I think, the main use case for that kind of behavior.
You also maybe just have a server that you want to take down and
Yeah.
eventually. So what
Exactly.
we could do is that we do a shutdown, but we still keep a thread open or do a fork and then do something that only sends a redirect.
Well,
This would also
we can do it with a separate modification of the server, but the idea was basically that the monitoring tool or whatever controls the server, it sets the redirection and then it waits and then it shuts down.
I understand that, but maybe we could also do something in the server to do the same thing, basically keeping it up forever.
Let's do a quick check on time. How are we on time?
No,
We don't have time. We have negative time.
we have 15 minutes negative time. Anyway, so it means that
Thank you very much. Thank you very much. Any questions, please refer to me or somebody else later on. We can continue. I hope to continue discussion of this elsewhere, so this is just a quick one. My apologies for this being so long. I'm just going to leave it on the table.
No, I
I understand it. Okay. I think it's done well. Yeah,
Do I still have 1 hour?
Well, not according to the schedule, but can you say now when you start the schedule for updates, because we are not off.
Sorry?
Can you please say that updated scheduler is on the web?
Okay. 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 Hello, everyone. I've been told to tell you. Okay. Yeah, much better actually. Hi, everyone. So I've been told to tell you that the updated schedule is on the website. So this is my my talk, MariaDB stored procedures and why they should be improved, or actually why I think that they should be improved. I'm opinionated, just like every sentient being, so what I will say is my opinions. You are totally free to disagree and tell me. Anyway, so short agenda, I will tell you why stored procedures are important, at least to me. I will give you some nice examples of existing libraries, and I will give you a list of the improvements that I think we need to write more helpful procedures. So, why are they useful? Well, from a user perspective, stored procedures can be seen as an API that database administrators or engineers can maintain so that they can write maybe complex queries or optimized queries, or I don't know, sequences of queries and transactions, so that developers just have to call them. Why? Because, well, we all know that most developers just want to use ORMs and they don't want to write any SQL. And it doesn't matter how wrong they are, fighting them is totally useless. They will win, and let's not ask them to write SQL if we can avoid that. Well, also they can avoid some network I/O overhead. Why? Because simply they are a sequence of queries, right? If I want to run 10 queries in a stored procedure, I will call the procedure once, obviously. For the same reason, we will have shorter locks, right? Because instead of sending a query, having a log, sending another query, getting the results back, and blah, blah, blah. Well, I will do this in a procedure, so I will avoid the overhead of the network communications. And also you can write them once and call them everywhere, which was old Java slogan. What do I mean? Well, maybe you have several applications connecting to the same databases. Maybe they even use several languages, not the same language. Maybe some applications are not even maintained. If you can use stored procedures, it's much easier to change the logic used by several applications. And then I want to give you a community but also vendor perspective, I think. So basically, procedures are an easy way to add callable code into MariaDB. So even if you don't know how to add code to MariaDB itself, maybe you can't write a plugin, well, you can add procedures in SQL. It's easier, and usually you can obtain an acceptable result as a minimum. Okay. They are also easier to distribute and install compared to a plugin or user-defined functions, right? Because you don't have to compile them, you just provide them as a set of SQL statements. Some MariaDB features, in my opinion, could have been implemented as stored procedures, and the result could have been acceptable. I'm talking about things like kill query, if exists or not exists, set statement, yeah, stuff like that. Okay, so if what I said is true, why isn't this happening? I mean, why are people not using stored procedures? Well, there's a cultural problem that I will not mention here. Well, I will mention, but I will not dig into it. A lot of people think that a database server shouldn't contain logic. I disagree with that, but anyway, I will not dig into this. But some of the reasons are related to MariaDB implementation. So MariaDB stored procedures are still a bit too slow. They miss features that would make development easier, especially if you want to write generalized code that can be reused in several contexts.
How did you find too slow? Based on what? I mean, I can think some reasons, but from your point of view.
Yeah, I'll anticipate the next slide then. Oh, sorry. Yeah, the next two slides. If I just run a loop from 1 to 1 million, it takes almost 5 seconds. It's still half of what it takes in MySQL, so from a perspective, it's a great achievement. But
we just improved that 3-4 times last week.
Sorry?
We improved that one 3 times last week.
Oh, well, that's great to hear. I will wait to see the next version then.
But the increment. But there's lots of things that can improve. I agree.
Yeah, I think that in general I can say that the code execution is a bit too slow. But again, I don't know which improvements you made last week, so I will wait to see them.
30 seconds. So what we note is that between each statement we have a huge line of code. I mean, that many lines on the screen, a big screen, basically just resetting things. We don't need to reset things for between the statements that just do for increment set variable. We do that. So all this step has this reset that is huge. We kind of remove that for simple things. And that improves the other ones. Selects are still as fast as the select, but the logic for handling stored procedures is not much faster.
Yes, okay, thanks. again, this is half of the time it takes on MySQL, so even even this is much better, but still, I hope that the last improvements make them much faster. The last thing I wanted to mention is there is no native debugger. This is a problem if you want to write complex stored procedures, right? Maybe it's not a problem for trivial ones, because you can just add some selects to output some variables and debug in this way, but still not ideal even in that case. I wanted to mention that actually MariaDB made some great improvements to stored procedures if you compare them to MySQL. Well, the most obvious is it has a PL/SQL parser, so it can parse a lot of Oracle stored procedures. To be honest, I will ignore that for the rest of the talk, but I mean, it's great that we have it, but I will talk about the native language for the rest of the talk. So some cool additions are things like execute immediate, begin not atomic. Sometimes they look trivial, but they aren't. For example, execute immediate can be very useful when you have a procedure that calls itself recursively. You have recursion. So because if you use the long version, so prepare statement name, execute, deallocate. Basically, what happens if you call, if you do this in a procedure and the procedure calls itself, you try to redefine a prepare statement that already exists, right? Because a prepare statement exists in the session, not just in the procedure. Okay, I've shown this. I think that there have been very interesting examples of stored procedures libraries. Actually, most of them are not maintained anymore, unfortunately, probably for the reasons I've mentioned. But I still believe in these kind of things. In case you don't know them, well, Common Schema was a great framework developed by Shlomi Nock. It even included a sort of internal language, and it could do a lot of interesting things. Well, the second one is very old, actually. Not many people remember it. Probably it was written centuries ago by Giuseppe Maxia. The intent was to add some missing features to stored procedures, but I'm not sure it works nowadays. The third one, unfortunately, was maintained for a short time, I think, but it was very useful, especially in the past, because when MariaDB and MySQL didn't support roles, you could simulate roles with SecureReach. Probably it still has some useful function, even if roles are implemented natively. For example, it can clone a user or do some other things. FlexUse was written by Justin Sonert, and basically, well, it's not just a stored procedure library, it also includes some other components, for example, to read the binary log, but it is a great example of library that simulates a feature, because basically it implements materialized views. MyTab, UT-MySQL, and STK unit were all unit test libraries. before someone accuses me, I have to admit that the last one was made by me, but don't use it because the code was horrible. And the last one is actually the funny thing that you see in the image. I wrote it just to have fun and to show that, yes, you can use stored procedures to write ASCII games. This is the hangman. So, talking about missing features, I think that the main one is external languages, right? Because, okay, SQL is great for queries because it describes what you want to have, and basically it's English, right? Everyone understands it. And then to write stored procedures, procedural constructs were added, but to be honest, it resembles archaic languages like COBOL, and it's not a cool language to use, to be honest. So I want to look sometimes, occasionally, at PostgreSQL to see what they do, because I think they are great in this area, in stored procedures, I mean. PostgreSQL supports natively SQL and C, and also it supports other languages that can be implemented, and a lot of languages were implemented by the community, actually. You can find a list at this URL in the wiki. It includes both interpreted and compiled languages. The list includes Python, JavaScript, PHP, whatever. Now, if I can make a suggestion about implementing external languages, well, Python is a lingua franca, right? Every data engineer knows it, every analyst probably, any DevOps. Okay, so generally it's a great choice. But at the same time, I think it has problems, right? Because normally when you install a Python script, you want to do it into a virtual environment, right? So in that environment, some modules exist, but this doesn't affect the other scripts. I don't think it's possible to do it in a database, probably, so I would also recommend that Python is not the only available choice we have. So, yeah, sure.
So, a little bit more than 10 years ago, Anthony Curtis and I wrote pluggable external language stored procedures, and we were basically done with it. We had it working for Perl and for Java, two very different languages. The reason it didn't end up in the server was that there really wasn't enough interest in it. There wasn't enough demand for it to get priority for review and similar. So do you feel like that part of the landscape has changed? Is there more demand now for this than there was at that time? Well, I can't speak for other people, of course, but I think it would be useful, and I think if I think about people I know, I don't know, customers or other people I know, there are people who could write stored procedures in PHP or, I don't know, Python, Perl, or something else.
Maybe it wasn't.
Sorry?
Sorry for stepping in. Maybe WASM is the area of interest because it basically allows you to run not a containerized, but semi-containerized software that doesn't affect the host system. So you are safe from running anything in WASM. I was talking about sort of this shortly because it might be a good idea because people would be allowed to enable to write just anything they want and to run it on a host without any security breach consideration. That's a good idea.
Yeah, and now that I think more about it, Probably one difference is nowadays there are many more, data engineers, and many of them could find it useful. Maybe, for example, to interact with external APIs. That is a use case that didn't exist 10 years ago, probably. Okay, so continuing with my list of missing features, let's go to procedures input and output. The input part is, I think that if we want to write reusable stored procedures and distribute them as open source, it would be nice to have more flexible ways to use them. So we probably need optional arguments, variadic arguments, so a variable list of arguments, overloading, okay, that is optional, but PostgreSQL has it, and I think it's very interesting. Anyway, a bit more about it later. And then the last one is actually a PostgreSQL syntax that just makes code easier. You have to make less checks at the beginning of your procedures, basically, right? And talking about the output, there is only one thing I ask, which is, please give us table functions. Okay, I will return on all these things. So for some of the things I mentioned, there are Jira tasks, requests by users, basically. So about optional arguments, well, I think it's simple as this, right? Adding a default clause after an argument specification. Variadic arguments, well, here I used, if it's correct, I used the C syntax, but it doesn't matter. I mean, it's not a matter of syntax. We can use any other syntax. The idea is to have any number of arguments of the same type. Of course, to access them, we would need two additional functions or variable, I don't know, whatever, which are the classic argc and argv. Okay. Talking about overloading, as I mentioned, Postgres has it, and basically in Postgres, procedures in the same database and in the same schema can have the same name as long as they accept or return different types. Okay. So yeah, I made a very simple example here. For example, we could have a get month days function which can accept an integer or a varchar. Actually, in the example, I also included a default value. Okay. Again, I think it's useful if you want to write things that can be used by several people, and you don't even know those people. Everyone has different habits. It can be helpful. The last thing about input-output is table functions, because I think they are kind of implemented in MariaDB, but not for stored functions, just for built-in functions. Because now we have this JSON table function, right, which returns a result set. So my hope is that this means that infrastructure has been added to provide this feature. If we could return a result set from a stored procedure, this would be very flexible from my perspective. As I added in the last line, well, ideally, it would be great if table becomes even a first-class types, meaning that you can use it for variables or whatever. I'm not asking weird things like adding a table inside another table. I'm not asking something like that, just for variables and parameters and return values. Actually, the last thing is this. As I said, this is a PostgreSQL syntax. You can specify returns on null input, which means if any of the parameters are null, just don't run the procedure at all. So it's also an optimization, and just return null. Most built-in functions probably do the same. Code on null input is just a verbose way to do the opposite. Okay. I also suggest some optimizations. For example, inline functions. Actually, between parentheses, I can tell you that yes, Postgres has them, but they are quite disappointing because it only supports very simple cases. This could be an area where maybe you could easily do better. Basically, the idea is when a function is simple, you could, and it is called inside a query, the original query could be modified to include the function. Okay, in this example, we have a very simple expression, right? And a select that uses this procedure could become this. It would probably use an index, and I think it would be an optimization. Okay. The other thing is a syntax that you actually have, but I think it has no effect nowadays, except for giving us an error if the variable trust store procedures authors, something like that. If it is not set to 1, we will get warnings or errors. But basically, I think it should be used as an optimization, because if a function is deterministic and it doesn't write data to tables, the results can be cached. Okay, so if I call it twice with the same parameters, probably it shouldn't run again. PostgreSQL also has a kind of semi-deterministic mode, which is stable, which means the function is deterministic inside the same query. Okay, so if it's called several times in the same query with the same parameters, it will return the same value. If it's called by 2 different queries, it might return different values, even if the parameters are the same. Well, basically, in built-in functions, something like that exists, I think, because you can have now which returns always the same result in the same query, but cstate can return different results, even in the same queries. Yes?
I think deterministic is very well used inside the server. The results are not cached, but it affects how optimizer treats the function, how query cache treats the function. So deterministic is used.
Okay. Okay, that's...
So if it's deterministic, then optimizer knows that for same values it will always return the same results. It can do more optimizations with the expressions that use the function.
Okay.
And then it also can be query cached. And if it's non-deterministic, then you cannot do it.
But if I understand correctly, it works in the same query, right?
Yes, it's all for the same.
Okay.
So optimize the query, and if
Okay.
the function is deterministic, then it can do a lot more optimizations around it.
Okay. Well, I think it would be interesting if there was a sort of global cache. So
Yeah, so cache is
just
global cache.
Why?
because suppose that many different connections call the same function, and often they use the same parameters.
And if they do not use same parameters, it will be just slow down.
Well, this is,
Yes.
yes,
Well,
it's probably...
in that case, a workaround for the user could be just not to declare it as deterministic. So another interesting thing that Postgres supports is create operator. But I'm not suggesting to support this syntax. I just want to look into what it is. Okay, because an operator in Postgres is a function that you define and some hints that you give to the optimizer. And actually, you could do the same for any function, in my opinion. So, for example, Postgres allows you to give hints about function execution cost, a communicator function, a negator function, and a restriction function. So commutator function is just, as in the example, greater than or less than are obviously commutator because you can just switch them and change the order of operands. A negator, well, it is obvious. A restriction function is probably a bit more interesting because it's a C function in Postgres. It's a C function that estimates the selectivity of a function. An interesting thing is that actually you don't really have to write it because there are some generic functions that can be used in several cases. Okay, for example, Excel or Nexel, they estimate the selectivity of equal or not equal, but in practice, they are often used for different functions. They won't be accurate, but they don't need to be. So, yep.
No, just curious. So this is features that Postgres has, but did you actually use any of that in your experience?
No, I can't do that.
I can tell you for sure that Yandex uses it. They basically define these algebraic types and define operators for that. But you need to have custom types to be interested in.
No, this is for. So this is talking about storage functions, storage routines. So if for storage routine you can specify. Storage function specify another function, which is negation of the first function, that the optimizer could do in purely transformations. I can see that it's theoretically useful. I'm just wondering if it was practically useful for anything.
Well, but as I said, the interesting part is if you look at these two examples, right, Excel and Nexel, they already exist. You don't need to write them. When you write a stored function that will have probably similar selectivity to equal, you can just specify Excel as, I mean, it won't be precise, as I said, but probably it won't matter a lot. Postgres also has some others, not just Excel and Nexel. It also has functions for greater than and so on. But probably the most simple cases are enough. So last part is about types. And I think there are a couple of things here, which are arrays and polymorphic types. So arrays, well, of course I know that you can have JSON arrays, but the problem is if you want to use JSON arrays as arrays in a stored procedure and then loop over them and do all the things you would do with an array, probably you would end up writing, verbose code, okay? That's the main problem. they don't help you to write more understandable or easier to maintain code. And also, of course, proper arrays would be faster, at least this is what I expect. So it could be nice if you could add arrays. I'm not asking to be able to add arrays to tables, but that would be useful for different reasons. Yep.
I'm just wondering if you're talking about multidimensional arrays, if they are presented in Postgres in files.
Well, yes, they support them, but I'm not asking that, honestly. I never used such a trick in a database.
Plain arrays to be available in the storage procedures. Okay.
In Postgres?
No, I'm asking whether you are interested in introducing the multidimensional arrays that, as they are in Postgres and another database.
No, not really. I mean, simple arrays would be enough, honestly.
Have you used row variables? I mean, you can basically use those as arrays.
Sorry?
The row, you have a row type.
Yes, I think it's only in the PLSQL version, right?
No, it's also
okay.
But
Okay.
I don't think you can iterate over all the values of the row.
I think you can access them by
You
number.
can access them by name, but you cannot iterate over like an array.
That should be easy to do. Actually, adding arrays using the row type would be kind of simple.
Yeah, it would be useful in my opinion. Yeah, last thing is polymorphic types or generic types actually. I mean, not only Postgres, but probably all major DBMSs have the any type, at least in procedures and functions. Sometimes it's useful because, you know, when you write a generic function, maybe it could work with different types, and you don't want to just convert everything to strings, because if you do it, the ordering will be different. Sometimes it's acceptable, but sometimes it's not. Okay, so this was the last thing, the last request. So that's all. If there aren't more questions, I'm finished.
Well, I have one comment. I'm not really an expert, but maybe you can say in Postgres there is some integration with LLVM. Do they have that for procedures?
Sorry, I didn't hear you. Integration with?
The LLVM backend is something that the client compilers use. And,
yeah.
That could be used for basically, that's a popular way of compiling different languages to something executable. So I was wondering if there is any LLVM IR backend interface in any database that you could basically compile your program in any language and then the database execute that.
In other databases other than Postgres? Yeah.
Postgres already other, yes.
Yeah, Oracle, SQL Server, DB2 have it. I'm not sure about others, honestly.
But do you think it would be a good idea, or?
Yes, I think it would be very, very interesting.
So we could probably do the Postgres way to implement support for routines in C, and then using the system API, there could be Python or Cloud anything could compile into that all that kind of thing. First, there need to be for executable code to work with respect to routine.
Okay, if that's all, I think I'm done.
we know to be wrong.
Exactly before.
Roman, you started 11, right?
Hmm?
You started 11?
I think so.
Yeah, okay, perfect.
Yeah, that's the idea.
Один сначала.
Okay, let's begin. Good morning, everyone. For those who don't know me, my name is Roman, and today I will tell you about the vectorization of the engine that was not supposed to be vectorized. And this engine is called Column Store, and that is the major OLAP engine for MariaDB. It has some properties, fancy properties, like it is column-oriented, and under the hood it is basically a massive parallel processing software that have a number of nodes potentially. And its storage schema is organized with two tiers. First, there is a data distribution between nodes, and every node have a number of Linux mounts that we call DB roots. Here's the schema for that. Many of you should know what vectorization of a software is, but for those who are not familiar, I will touch grounds with that. Here are two pseudocode snippets that demonstrate the processing of a scalar values, and there is a counterexample for a vectorized execution. As you can see at the top, we are talking about this particular expression, a simple one, a mathematical addition. And on the left, we see that we iterate over the rows in a certain row group, and we plain just get the value of the column and sum these values up of these columns. After that, we append the resulting value into the output. And that's all. That's how scalar processing works. In the vectorized world, we iterate over a vector that might consist of a number of scalar values. It's usually the power of 2, like 2 values of 4 or 8, 16. And we sum up these vectors. And it is basically the same what just algebra math does for vectors. We sum up separate scalar values of these vectors, and in the end we have a vector that have these sums. And we take this vector and add it into the output. So basically we'll do, let's say, 4 or 8 or 16 math additions at a time. So to go on, I need to share some context with you about the internal representation of data in Column Store, and we call it RG data. And the format is pretty straightforward. There is a fixed size header. After that, there is an array of rows. We call this part a typed column buffer. And this typed column buffer consists of a number of fixed size columns, and the sizes are power of 2, starting from 1 and end up with 16 bytes. And there is a potential string store buffer, where variable size strings belongs to. So looking at this format, one might ask about how it is suitable for vectorization. And you will be right, because you know what? To get a vector, to collect a vector, you need to run so-called gather operation. And unfortunately, in the SIMD world, single instruction, multiple data, that is an acronym for vectorization, widely used. There are some architectures or instruction sets that don't have these gather instruction. For example, a widespread SSC 4.2 available at x86 architecture doesn't have the gather. So to collect these separate values to construct the vector that I told you about in the previous slide, you need to do it in a scalar manner. Basically iterate over separate rows and extract the value over certain columns, let's say column 1. That's not very fancy, not very fast. Moreover, this particular format, it cannot enforce the certain alignment for, let's say, column 2. You cannot always tell that its address starts with the it is aligned with 16 bytes. So, very unfortunately for us, most of compilers use the aligned version of the instruction. For example, the thing that we step over a lot, that is a move DQA instruction that basically moves the vector of data to some other place. And you know what? If you run this instruction and supply it with the unaligned address, you will end up with SIGWare signal. So we basically crash. Fortunately, there is an unaligned version of most instructions, but compilers don't allow us to control when it put the aligned version and when it doesn't. So unaligned memory usually is a big problem for the vectorized execution. There are two potential workarounds for this. One of that I already mentioned, used the unaligned version of the instructions, and another one is to use this attribute describing the structure itself. But both of them are impractical. It basically takes a lot of code to just describe that you need. There is a third workaround, but it puts enormous overhead. It's basically to enforce that all the columns are aligned. So we end up with a lot of extra memory that are unused. So with that context, I would like to describe you what was the state of affairs just before I start the project of vectorization column store. First of all, to just highlight how it was, there was a flag not revectorize. That basically tells there will be no auto-vectorization of loops, no matter what. And that's a good thing. I suppose back in time, the authors of column store, they fight with that problem with unaligned memory, because if you have suddenly moved the QA somewhere and you have unaligned memory, you end up with crashing, and nobody tells you why. Because in optimized code, you see that the execution points to a certain instruction that doesn't correlate with actual instruction that is running on the process now, where it crashes. So the second point is there were actually no suitable loops for auto-vectorization, even in places where you naturally could see the auto-vectorization where it fits naturally, like the scanning part that operates with vectors of 80 kilobytes. Even there was scalar processing. Like we iterate over all values in the buffer. For a value, we check whether it is a null value or deleted value. We have special values for that, magic ones. And after that, we try to apply the filters that we have, a simple one. And if the filter satisfies, we just put it into output. So this pseudocode correlates with this particular example, with this particular expression. So, given all that, I arrived at the goals of this vectorization project. When you hear about vectorization, in most cases that is about speeding the things up. Like if you process four things at a time, 4 values at a time, it will be faster when you process one value at a time. So the main goal is to make things faster when it is possible. And where it is possible is an important part, just because there are some SQL operators that, in my opinion, naturally are scalar-oriented or row-oriented. It is still arguable, as I point here, so if you have your own opinion, I'm happy to hear you. But in my opinion, hash group by, hash join, and order by, they are all row-oriented. That means that it is easy or has less overhead to process them when the data is in a row format, not in a columnar one. So, and to make things to complicate something, to make it a bit complicated, we need to support two widespread architectures. So the vectorization have another parameter. So let's define a number of issues that we need to resolve whilst we're doing these. The properties of the you cannot change all of the processing from scalar to a vectorized version in one go, in one try. You cannot do it overnight neither. So I decided to pick a certain specific facility that is easy to change and where I can see the outcome clearly. And for that purpose, I decided to take the scanning part that I already mentioned that works with the vectors of a fixed size. And this scanning works with column types that fits into the 8 bytes, like 1 byte char or 4 byte integers. And also this scanning processes a simple filtering term that consists of comparison operators and some logical functions. And as I mentioned, the morsel size of this facility is 8 kilobytes, and that corresponds with 1 kilothousand to 8,000 values, because we have different column types from 1 byte to 60. At this snippet, you can see the pseudocodes for scalar execution of this facility, and that's basically a core of the execution. And let's consider this example that we already see. We just try to pick up all the column values that equals to 42. And in a scalar, what we do? We iterate over values, and then in the buffer we compare whether they have a special meaning or not. And if they don't, we try to filter. We try to apply this filter equal 42. And if the filter doesn't work, so we either go to another value or we output the value into. We put the value into output if it equals with 42. The vectorized execution is a bit more complicated. It's a bit more involved because we compare the vectors. Let's say we are working with integer column. So integer column have 4 values in SSC 4.2. So we try to compare 4 values at a time. And as a result, we have a null mask. A null mask is basically the bits that are set to 1 if the equality is true, and they are zeros if they're not. After we search for special values, we make a bit, run a bit operation, bit end, and we get a filter mask. After filter mask, we iterate over all potential filters. And what does it mean? This argument, filter vector, it's basically a vector that consists of 442 values. And we compare it with the vals vector. And if filter mask have some values, have some ones set, then we store it into the output. And I will tell about this particular routine that stores the resulting potentially satisfying the filter values into the output. An important part is that there might be leftovers because you cannot process all the values. Let's say we have not 8,192 values, but we have 1 less. So we have something left, 3 values that must be processed in a scalar manner. So the thing is, pseudocode is very good and fine, but unfortunately there are a number of parameters that must be taken into account. For example, the size of the columns. That affects on how many values are in the vector itself. Like you can have 2 values for integer 64, you can have 4 values for 32, and so on, 8, 16. So this is parameter number 1. Another parameter is that the first parameter, the number of values in a vector, affects the second. Basically, the SIMD instructions have different names. We have different instructions to process different types of vectors. That is natural. And there are also floats. And floats are processed in they have another set of SIMD instructions to use. And there are also two architectures that must be taken into account. So we have a number of parameters that somehow need to be introduced into that pseudocode that I shared previously. Okay, here we go. There are a number of approaches how to tackle this parameter problem. The first is to use header-only template libs. The most suitable that I personally find when I start the project was SIMD, that means SIMD everywhere, and Agner's Fox vector class. And this one is interesting because it contains some routines for vector types that doesn't exist naturally. I mean, they have no instructions, SIMD instructions, but they are they're composite that consist of a number of other SIMD operations, SIMD instructions. The second option would be to use the function multiversioning feature of the compiler. Both JCC and Clang supports these, and what it is in a nutshell. If you take a look at this the snippet on the bottom left, you can see that we can define a number of architectures that have a different version of the same full function. It looks like overloading in some cases, but the overload factor here is not the parameter of the function, but the architecture. So internally, compilers uses the concept called ifunc, and that is a fancy name for RTLD dispatcher that is run in the very beginning of a runtime, and it picks the proper version of the function itself. So as you can see, the preprocessor basically masks all the code that doesn't belong, that is not available on this particular machine. So in the end, there will be a pointer to a function that is set by the runtime when the runtime dispatcher chooses the appropriate version of a function. So we have these two options. We also have a number of other options that are by its nature JIT-oriented, just-in-time translation, I mean, by JIT. And these are the tensor libraries that are widely used in machine learning. Like, if you consider a vector to be a tensor, one-dimensional tensor, so you can just use all the primitives that libs provides you with. Unfortunately, these options have a very high change cost. If we are to use one library, you cannot easily switch and start using another library. It is like this. So, to be honest, I have my master thesis that I wrote recently on this option, and I wrote the proof of concept code for this part. But I find it very, how to say this, clumsy. It's basically it forces to change a lot of code just to use this library. It doesn't look very attractive, to be honest. And the last option is to use the plain JIT to produce filtering cores, like that pseudocode that I showed you. It can be written in a JIT, but JIT itself, it's a complex beast. Like, to describe the function itself, it takes a lot, and given all the variability, all the parameters that I mentioned, it makes it even more complicated and involved. So There is a recent addition. The guys from Tim Gubner from CVI, they reported on this on VLDB on 2021, if I'm not mistaken, with this paper. They produced, this is not the only thing that I see, but they produced the DSL that describes the runtime. What does it mean? You have a special language that allows you to just define what are the operations, but the corresponding translator, Fuji, they call it, it can translate the this DSL into the either mix of scalar and vector processing, and at the same time it takes into account what kind of SIMD instructions sets do you have available at the machine. That's very appealing thing. However, this is the concept. These guys are from academia, so it's very far from being production grade ready. Nevertheless, it's very tempting to use that one. So we considered 4 approaches. We considered 4 approaches, and we have 4, but we need to pick only one. So we need to choose. There should be some consideration of why did we pick one over another. So the main decision that I made looking into all these options is that we have to somehow tell that we are vectorized now, so we forced to run column store only if there is at least SSE 4.2 or ARM Neon instruction sets are available on the platform, otherwise we just stop. Considering all the things together, I decided that we will go with the first option, and that is template header-only library. Unfortunately, we cannot use the existing libraries like SIM Everywhere or Agner's Fox vector class out of the box, because we have a number of parameters, like we have a different vector size, column sizes, and it corresponds with the different vector sizes, and it was not easy to translate into the primitives that are used by these libraries. So we basically rewrote library, reinvent a bicycle once again, unfortunately. However, this library was handy to describe that core pseudocode that I already shared with you. And here on the right, you can see the snippet of the class that basically describes the processor that takes into account the type of the vector, and that vector type basically tells how many scalar values you have inside. And as you can see, it have a number of types that are rendered in compile time, and there are a number of functions that are used by that scanning code. And as you can see, these functions basically use the primitives that are defined in the libraries itself. I need to mention that with this approach, we only support the SSE 4.2 and ARM Neon. There is no IOX and SVE instruction sets are used. So, I probably won't show you the whole code and the other things, because it's there are a lot of lines in there, and if you are interested, you can go into into our repository and take a look yourself. However, here are the results of the project. We implemented the vectorization for x86. That was implemented in column store 6.x, and a bit later after that, like 6 months later, we implemented it for ARM64, and that was made by JSOC student, last year JSOC student. To be honest, I was very disappointed with the results, because The micro benchmarks demonstrates like 10x speed up. That is great. I love it. Unfortunately, when it comes down to the real world filtering intensive queries, it only gives us 30 to 40% speed up. That's not huge. It's not even what I expected. However, this fact made me wonder what's wrong with that. And I discovered a major bottleneck that we have in our software that basically prevents the vectorization or any other speed up that we potentially introduce like JIT to demonstrate the effect. And these two are the shared synchronization primitives, basically mutex. That the first one is a lookup structure that is used to look whether this block is already used by another transaction. We call it VSS lookup structure, and it is shared. It is shared and used by every block access. Another mutex that affects the performance, basically reduces the performance from the vectorization, is the block hash access mutex. That's a widespread thing for database engines that have a common buffer cache. So all the scans also use it, and you can imagine how often it is accessed, and there is a contention on both these structures. So I have the work in progress PR that basically gives me a 2x sped up comparing to the current code. So that looks promising already. It's not still 10x that I saw, but nevertheless it's 2x already access. That makes me more happy. So there are lots of plans in this field because this proof of concept patch that I mentioned, it basically gives me some hope that there will be a significant speed up. So I will finish that patch first because it unblocks not only vectorization effects but all other speed up effects. And the next fields where we want to apply the vectorization would be the group by, and I hope that Teresa will be working on this. There is a special implementation of group by that leverages the the original Robin Hood hash map, and there is a very attractive loop that might be vectorized easily. And this loop is used very often, so we can decrease the lookup time for this hash map. And to be honest, I want to apply this function multiversioning that I told you about previously, because it would allow us to leverage all the instruction sets available at this particular platform. Like, if you have AVX512, why not use it? So I want to try this.
So the versioning in column store, how does it work? Because you usually have that, you have a list of transaction ID that says is this visible or not, that you have to go through.
I don't think that I get the question, because multi-function versioning works in when the runtime starts, when the software starts. And it just puts the pointer to the function into appropriate place, and after that the software uses this pointer. Like there is a dispatcher.
No, but I mean internally the multiversion. So what does the multiversioning, multiversion detection in column store?
Monty, can we talk about this a bit later, because it's away from the topic of this talk. But I can surely tell you about the transaction support and multiversion.
I mean, just is it checking that does this value exist in an array? Does it work that way?
It's a long story. I will tell you after that, if you don't mind. So the second, and this would be a major effort, to incorporate the wide-known Apache Arrow project. That is basically the format. That was, from the beginning, it was called a vector friendly. What does it mean? They have a format that differs from that RG data that I showed you in the beginning. It basically stores all the values as a columns, not at the rows. And that makes it very easy to iterate, to start iterating over the vector values in this column. However, as I said, it's a major effort because it takes a lot to change, a lot of changes. So we'll do it gradually, partially replacing and refactoring code. After that, there is another potential optimization for a group by. When you have a group of rows, you can calculate the hash values for these rows, doing the group by, or hash join, iterating over the column values. Yeah, like you can first multiply the values by a certain value, and after that you can move the results left to right, and do this in a vectorized manner, processing 4, 8, or 16 values at a time. That looks tempting and should speed up things because hash calculation is used everywhere and it's used often. Another option is to boost unordered flat map. I didn't put it, but it is available since boost 1.81. It is a recent edition, like October, maybe December 2022. And if you are interested, you should interested into the internals of this hash map and why it is tempting. You should take a look at this paper. This is the first known, open sourced version of the hash map that has a SIMD-based speed up for hash map lookups. I will not look into details of this technique, but I suggest you to take a look yourself. And the last thing, but very important, but it is a bit far from now, is the auto-vectorization with JIT, because the JIT itself, let's say de facto LLVM is the main platform to produce the JIT code, JIT symbols. It can optimize, there are some optimization passes that allows you to change the loops that's suitable for auto-vectorization, and that means they are written in a certain form, and replace these loops with the vectorized form. But as I said, JIT takes a lot of time to produce symbols, and this thing is even more complicated. So with that, I would like to thank you, and if you have questions and if we have time, I'm ready to answer them.
A question got,
You go first.
sorry, a question I got from the audience was, have you considered Apache Parquet?
We have a recent JSOC also edition from a Chinese student that will support this Parquet format. So in the first phase, we will support it as the format that we are capable of reading from. But with adopting Apache Arrow, I suppose we will have more options like reading from Parquet naturally. Because right now we have our own format, but I suppose after some work with Apache Arrow, after we adopt it, we will be able to read from Parquet files directly. Because they are very close to what we have in our format, to be honest. The only difference is that the row group, Parquet has row group put into one file, and we have them separate in column files.
Yeah, I have the question you mentioned the final step in something that wasn't still just loops which to copy into the output. So how's that implemented currently? Like, do you just move?
Good point. Very good point.
Yes,
I didn't tell about this just because I thought I have no time. The major bottleneck here is that this particular function. Let me scroll a little bit further. So to remind you, this is the vectorized pseudocode, right? We filter the things, and in the end, if we find some suitable values, we should somehow put it into the output.
So you end up with essentially a bitmap with ones for things to copy and zeros for things not to be copied.
True, true. And very unfortunately, we have only a scalar version of these. I personally didn't find a suitable way how to express it in a vectorized manner.
You can, have you read the paper, the sim JSON, which was quite a while ago? It's vectorized parsing of JSON, essentially.
No, I
It
need
has
to
a couple
confess.
of good bits. One example is using pop count to get only the, you essentially get the offsets. If you have a
So there is a way to compact values, because I basically have the bit mask and I have the vector of the resulting values, right? And this bitmap describes the values, and I need to compact these values. Like if I have something that I don't want to put into the output, I need to somehow ignore this.
Yeah, this is I work in MaxScale, and there's code there that essentially vectorizes the digestion of a query into canonicalized format.
Mm-hmm.
So we run into a lot of the same problems. So okay, what do? We have a bitmap, essentially pointers.
Mm-hmm.
So the SimJSON paper kind of used, I say, something motivated our efforts into this. We used pop count, first of all, know how many values there are.
Mm-hmm.
If you have 3-bit sets, it gives you 3. You know how, if you have space, how much space you need.
Yeah, makes sense.
And the same paper also, there's the count leading zeros. So you get a direct offset into that. So there's x86 specific ways you can do this with very little.
Right, but do you write with vectorized, with the simple instruction?
Well, you can vectorize it in like loop and rolling sense, but from that, the vectorized itself is not, because there's always a step where you need to kind of do that stuff.
That's the thing, that's what I'm looking for, and given that I have seen a lot of tricks for the vectorized code, I still hope there is a way to express. Basically, the algorithm is to somehow compress or ignore the values that are not satisfying us, and to move the future values that goes on the right of these values to ignore. They need to somehow be put into the output, ignoring this, something that is in the middle.
Yeah.
But I see your point. They basically produce some meta that allows to simplify, to add some conditions, and to try to not simplify, but to process edge cases first, and in the end you fall back to a generic version of it that is basically this one.
Okay.
Okay.
Just if that's the literal code, I think you can, if you have, how much do you have? 128 one-byte values, 128 if comparisons, and you can get that, and if there's only 1-bit set,
Right, but
so it's minor, but there's no way to kind of pick these, as far as I know. There's no instructions for that, at least in x86 support.
Right, but you are talking about leveraging these if conditions with the.
I mean, because you don't need to look at 128 times when you know there's only one. There's pop count is 64 bytes, I think, at least, for population that tells how many bits are set. So
I probably need to look into the.
I
into
recommend
that
reading the sim JSON paper. It has a lot of small tricks they use to like speed it up.
I appreciate this. I will surely ask you for the actual name of the paper. But to be honest, that is the question that I was very interested in, because I was open to suggestion on this one, and that is very good that you find that you saw
You
this.
ran into the same problem, I guess, is what
Some of the problems are universal, you know.
Yeah.
Okay.
Relation types that we support. Equality, right? The types of relation that we support, it's a question, right? Equality, you showed, right? Equal 42.
We support all the potential comparison operators that we have, and I support all the data types like character ones also, because I didn't touch the character data types scanning and filtering because it is way more involved. There is a translation from the from what we get from the buffer and what the char set can work with.
We support greater than, less than also support?
We support all the comparison operators.
In-list,
Huh?
In-list.
List?
In-list.
In list, it's in list have two processing paths. If the list is short enough, like if I'm not mistaken, it is 5 or 6 values, it is translated into the comparison, equality comparison end. So we have column and column equals something and column, the same column equals something and 6 times. It is faster. But if we have more than that, we just put everything into hash map and we apply this hash map iterating the values. So I would say that if we have a long list with applied for integer columns, that makes it more complicated. But nevertheless, there are some ways that involves both the vectorization and this in processing. Okay. Thank you very much for your time, and with that I will finish my talk.
Okay, so let's try it like this. So thanks for joining. So I'm Christian Nielsen. I'm a long-time MariaDB former MySQL developer. I implemented some MariaDB replication features, group commit transaction, global transaction ID, and parallel replication. free software developed for a long time and also do consulting independently. So in this talk, I wanted to be a little bit philosophical, and I want to define what I think is the very core of MariaDB replication. And then I'm trying to show how that in turn determines some of the key properties of how replication works. So what is core? So this is, in the core we have a master server. It runs some transactions in parallel. In different orders, we have multiple connections. And then when a transaction commits, we write the transaction into what we call the binary log, the bin log. And we write it in the order that the transaction commits. So that's very basic. And the fundamental, I call it the fundamental axiom, is that when we have this binary log with a sequence of transactions, if we on the slave apply them one after the other in order, we get the exact same data on the slave as we get on the master. So this is the kind of the fundamental axiom how replication works. Just to make it more concrete, so here's a diagram. So we have here 3 transactions. So T2 is the one that starts, but T3 actually is the first one that does something. It deletes something, it inserts, T1 starts. And at some point, like here, it's they both try to update the same row, so they have to wait for each other. Some synchronization needed. At the end, T1 commits first, then T2 commits, and then T3 commits. So in the bin log, we have those in sequence. And now the fundamental axiom says that if we apply this, it will always give the same result on the slave. And that's actually a very strong property, especially for statement-based, if you have SQL statements. Like I think, and the reason it works is that InnoDB has some very intricate locking. It has not just exclusive row logs, it has shared row logs, it has these gap logs and insert intention logs. So it's really a lot of work went into making that work and make it work efficient. But this is really the property that we have this, as I say, if you apply them in sequence on the slave, we get the same. Remember, they will run in parallel on the master, but they run serially on the slave, we get the same data. And this is the basis, basically, of the performance of Maria replication. It performs really well. And also, it's very, very flexible compared to many other replication solutions. But it also gives some limitations. So that's what I want to kind of demonstrate how important this actually is. But also, I really like having a two-way dialogue compared to just me speaking for 45 minutes. So just ask me anything about replication questions. I'm happy to answer that on the way.
One remark, InnoDB doesn't have row logs. It has index record logs.
Right, okay.
So it has, depending on the access path, which secondary indexes it is using, it can acquire a different set of logs on the master.
Right, so if you do a table scan on the primary key, in the clustered index, it will have an index record log on the primary index.
Yeah, that
clustered index.
If you are modifying any row, then it will have to have a log on
modify, okay.
Primary key index record, but whether it logs any secondary index records, that's depending on the access path.
Right, that's a good point. Yeah, so InnoDB is actually clustered index implementation. So the row, yeah, okay, it's interesting. Thanks.
But on the slave, we basically always do a primary key lookup and then update that one. We basically never use the secondary indexes.
Yeah, if there is a primary key, we still allow replication when the primary key is missing.
I mean, statement-based replication, it uses whatever, right?
Yeah, but let's say most production servers now uses either row-based or
mixed mode, for sure, yeah.
And mixed mode will basically use row-based in most cases.
Yeah, I mean, yes. So definitely row-based replication is much simpler. Statement-based replication is actually very scary. But even if you have row-based on the slave, you still have the SQL statement on the master, actually. Yeah. So let's start with one consequence of this. We have a parallel replication, especially what we call in-order parallel replication, which was implemented some years ago. So we have this axiom, if we apply the transactions one after the other, it works. We used to do that. It's not what we want to do for performance. It's too slow, right? Modern hardware, we need to do it in parallel. So how can we do that? And the idea in this in-order parallel replication, it's also called optimistic parallel replication on the user level. It is that we just try to run everything in parallel. Just start it. We have 10 transactions, just start them in parallel. But when they commit, we make sure that they commit in the same order as they did, as they are in the bin log, which is the order that they were in the master. And sometimes that can result in conflicts, but if it's a conflict, we detect it quickly and we resolve it. So like in the ideal case, so imagine this is the binary log. We have transactions 1, 2, 3, 4, 5, so on in sequence. And now we have 4 threads. So let's say we just start 1, 2, 3, 4. We start them and they finish, and when they finish, we commit them and then we start the next one. So if all the transactions are the same size and they schedule perfectly on the threads, then we have the perfect scaling, but of course that's not very realistic. So what happens in this in-order parallel replication in practice is that the transactions start, and maybe number 3 here is a little bit delayed. There was some other thing going on the machine. And then transaction 2 is much longer than the others. So remember, we had to commit them. We can start them at the same time, but we have to commit them in the same order. So 3, 4, and 5, and 6, they have to wait to commit until 2 committed. So we have some wasted time, which is kind of the lighter colored boxes here. We have a lot of time where transactions are waiting, and also some time where they're not scheduled. So we actually need more threads than you would expect probably. And you actually should use a lot of threads with parallel replication, I think, more than just like number of cores or twice the number of cores. It is implemented so that they scale very well. So this is the idea of parallel replication. And how can we be sure this works? I don't know if you can imagine how many corner cases there are, especially in statement-based replication, of different, like there are foreign keys, there are all kinds of selects, optimize of different paths. How can we be sure this works? Like, just run them in parallel, see what works. And there's an argument which is based on this fundamental axiom of parallel replication. It is that even though we ran them in a very different order, the transactions will run in a different order on the master, but we commit them in the same order. So that means that the bin log, which just reflects the commuter order, the bin log is the same on the slave as it is on the master. So by this fundamental action, we know that they run, the bin log is identical, so they produce the same data. If we were to replicate it serially, it would give the same data. So they must be equal. And if there was somehow the parallel replication would give a different result on the slave than on the master, that's already a bug in non-parallel replication, because the bin log from the slave would then apply incorrectly on the secondary level slave. So it's kind of a relative correctness argument. If it works for serial replication, then it also works for parallel replication. I think that's a very strong property in this way. The reason that this was possible to implement in a way that it works. There's still bugs, but yeah, it wasn't like I had to consider every single corner case. I think it's a very strong property. So I just want to mention, this is a good theory, right? We have a correctness proof, it's a relative, but there are some really tricky corner cases hit by parallel replication, which were bugs in InnoDB, you could say, but it's something that wasn't triggered before. This is from memory. Maybe, I think it was like this. We had some transactions. 4 transactions, they all update the same key. They all update the same primary, the same row. So there's an update of this row. Then after that, there's a delete of that row. Then after that, there's an insert of the same row and a delete again. So we just have a row, we delete it, we insert it, and we delete it. But on the slave, we run them in different orders. So we delete the row, and then we delete it again. And after that, we insert. But what happens is that they run in parallel. So the update takes a lock. So these are waiting. The 2 deletes are waiting. And then we do an insert, it's also waiting. But we have to commit the insert as number 3. So what happened is that we insert the row, we delete it, we insert it again, but this delete already started, it was waiting for the lock up here. And it missed, because it saw that the row was deleted. It missed that it was inserted again. So this delete did nothing. on the slave, parallel slave, and this one, this insert was on the left.
And it was the second delete silently ended, right? Without producing any error.
Yes, yes. So this delete was supposed to delete something and didn't delete it, and then later you'd get a duplicate key error. And it's a bug, but it's not very often probably that an application would delete its rows before it inserts them, right? It would be unusual for an application to run the delete for the insert. So that's probably what was caught before. So it's tricky to get correct, but it's, at least theoretically, there is an argument why it works. But still, I think this in-order parallel application is a very powerful feature. The good thing about it is that it basically just works. I was actually doing a benchmark for the second talk, and it was a little bit slow, and then I thought I'd just just enable parallel application. I didn't have to think about, does it work in this case? Do I need to partition my data? I could just do it, and it was faster. I think that's a very good property. And I think this is the key to have, at some point, parallel application enabled by default, because this will be transparent to applications, and it will. It has to work, of course, in all cases. But this is all the case. The reason we can think about doing this is because it matches with the fundamental axiom of replication that we have this property. But I'd really love to hear real-world experience of how this works in practice, this in order, if it performs well and if there are some problems. Yeah. Okay. What's the time? It's pretty good. Okay, so another thing I want to mention with this MariaDB replication, it's asynchronous. Because remember what we said, this, what I call the fundamental axiom, the bin log records the transaction in the order they were committed. So what does that mean? It means fundamentally we cannot write to the bin log until we commit, which means we cannot start a transaction on the slave until it commits on the master. So that makes it asynchronous. So the transaction runs on the slave after it's computed.
Optimistically, we could write on the bin log and then we could write rollback.
Yes, and there's some work started to do that. And again, so I had this, the core of replication is that it works in this way. And it doesn't mean that I say you should never do it a different way. In fact, we want to do it better. As you say, we want to do stuff like this. But then we have to be sure, and this is kind of the point I want to give in this talk, that if we do something more than this, following this fundamental axiom, you have to think really carefully, because then you're no longer protected. You don't have this relative correctness argument that I use for parallel replication. It doesn't work anymore. You have to then consider, is this the correct? So we'll give some examples of that. Yeah, because it is. What was it? Yes, so the problem with having this asynchronous replication is that because a transaction can only start on the slave after it committed on the master, we have a minimum lag of the slave of the size of one transaction. If the transaction is long or event, like in the alter table, it means we have a lot of lag. So this is the fundamental thing we want. This is, I think, one of the key things to prove. And you say, maybe we can do, like you said, optimistically run it. There's already a two-phase author which does this, yeah.
That means so that will be somewhat highlighted in my presentation.
Yes.
Yes.
And that's also another way to do it. It was called out-of-order parallel replication. But you should also realize that this asynchronous replication is the key to two very important things. It's the key to get performance, because the master is almost unaffected, relatively unaffected by the replication, because it's only at commit time you have to do a little bit of extra IO. It can still be costly, but it's much worse if you had to do a distributed row record log for every operation. And it also gives a lots and lots of flexibility. You can do really, some people are using advanced to do very complex things, and this is also possible because it's asynchronous. What time we're finishing? So I wanted to talk about another aspect of this asynchronicity. What does it mean? We have this term durability. What does it mean? It's stated like this: if you have a successful commit, after a successful commit, your data will not be lost, right? That's a promise of durability. Sounds good, right? You read this, data will not be lost, right? Sounds good. But it actually, while playing in this setting of replication, because it's asynchronous, it actually means that your commit will be delayed until after, right? And then it will fail. Because if commit fails after a long time, then you're durable, because you didn't commit, right? And it's actually the case that you have these semi-synchronous and enhanced semi-synchronous. It doesn't protect you against data loss. Your data will still be lost if the commit doesn't go through. It's just that you have ability in the application to handle it if you handle the commit failure. I think we all know this example, you know, I don't know, it's maybe a stupid example, like you type in a big web form, like in Jira or something, you type a long text, right? Spend half an hour doing it very carefully, and then you say, submit, and then you get an error. Because commit failed, right? So you lost your half hour of work. I'm sure most people have tried this. But the database was durable, right? Because the commit failed, so we were durable. But the rest of the application was not two-phase committing with the database, so the data was still lost. I'm just not saying that durability is not a good property. I'm just saying you should not overestimate what it means, because most applications, like WordPress or whatever, it doesn't have this durability itself. So you're going to lose data maybe in another place. You have to have a very careful application where every time you commit failed, you can retry and stuff like that. So it's and there is actually so if you really what you really want to have, of course, is that you during your query you have a transaction, and if the server you have disappears, you want the query to continue on the other servers in your cluster. It's kind of this way, and you need something like NDB or some other synchronous replication cluster. It's kind of, for me, it's the holy grail of databases. You want this cluster, it has some nodes, it's high availability because if a node fails, it just continues on the remaining, and it also scales. If you're too slow, you just add more nodes. And this is the holy grail of databases, but it's hard to make, right? Otherwise, somebody would probably make it. But replication does provide high availability of the database. So if the master goes away, you can fail over to a slave and your database is still running, but your actual queries will not be saved. You will not lose the data of the actual queries from the database point of view because we are asynchronous replication.
On the other hand, all transactional applications should do retries. So
yes, I agree. Do you think they do?
I think they do.
Yeah, I don't think they do, but it depends. Some do, sometimes. And of course, the higher level of operation you are, the better you will be there. But so you write your web application. When as the user types, you save it in somewhere so that if your web browser crashes, you can recover it, and you do that on the middle type. And if you do that, or if you have a bank or something like two-phase transaction, of course durability is good. I'm just saying there are places. Many of the users that we don't see because they don't even know the user database. So they are on a different level.
What is lost again, Christian? Can I just elaborate on that?
The thing is that it wasn't committed.
So the data is saved only after commit succeeds.
Okay.
Right, so you do 10 updates, and after number 5, your server disappears. Then you have 5 updates, and the transaction would be lost. But as Monty says, the application could then have saved the data and it can retry it. But not all applications are able to do that. I think I'll skip this. So another important point about how this replication works is that we have this bin log, and the sequence defines exactly, if you do them in sequence, we get the same data. So at every point in the bin log, if you have 3 transactions, T1, T2, T3, when you applied 1 and 2, at this point, the state of the slave, after applying these 2 transactions, it's identified by a single point in the bin log. It's a simple thing, right? It's just you have a single position in the bin log, and it identifies the state of the slave. So the slave can disconnect, it's a specific state, and it only has to remember where did it disconnect in the bin log, then it can connect again, and continue from there. I think that's a very, very good property. It's not just from this point of view and fundamental how replication works, it's also very good for DBA. What is the state of my slave? You have a position. In the old days, it was just the position in the actual file in the master, but now we have GTID, global transaction ID, and global transaction ID preserves this property. You just have one value, the global transaction ID, and it identifies what is the state of your slave. And so I really, when global transaction ID was designed, I really want to preserve this property because of this way I think replication works at the fundamental level. And MySQL does it differently. I don't know if you're familiar with MySQL, but they have a GTID set. Conceptually, the state of the slave in MySQL, at least when I looked at it last time, was conceptually it's a set of all GTID, all identifiers that you ever applied. So it could be like 50% of them spread out. And this is more complicated, I think, for the DBA and for the system as a whole. So this was actually the reason that GTID in MariaDB is different from MySQL, which is a very big decision to make. It would have been nice to have the same, right? But I think it really, yeah, so that's the reason to make it simple and to have this one-to-one correspondence with this bin log sequence. But again, I'd love to hear real-life experience. Is this actually simpler for operations, or how does it work?
Perhaps someone disagrees, but...
Yeah, someone disagrees. That's fine, yeah. And so this was, again, so we had this, I said, I lied to you, right? I said GTID, we have a single GTID, a single identifier of the state of the slave. And now I'm going to give an example where we're actually going to violate this fundamental way it works. We're going to do something more, and what is the consequence of that? So this is, for global transaction ID, we also have to consider multi-source replication. In multi-source replication, we have two masters, yeah, M1 and M2, and they replicate to a slave. So now we don't have this single bin log, we have two bin logs, right? We have two sequences. So the slave here will have one position in M1's bin log, but another position down here. So we have two. I don't know if you can see down here. So this is, in this case, the position is two-dimensional. We have, it's called the domain. The first number is the domain. So in domain 0, we have the position in M1, but in domain 1, we have a different position. So, and we replicate from that, we replicate from S1 to S2. So that's just a single. So now S1 is an intermediate master. So it's just a single bin log and a single replication. But we still want to have this two-dimensional. We still need two streams, right? Because at some point, S2 was replicated from S1, just a single bin log, a single connection. But now we want to move S2 to be directly a slave of M1 and M2. So when it connects to M1, it needs to know where to start. And it needs a different place to start than M2, so that's why even in a single, if you just forgot about this, we can have multiple domains. We can have multiple positions. So this violates this fundamental principle, right? Now we have two positions. But it makes this multi-source, it makes GTID work well with multi-source application.
It just vectorizes using the terminology of previous.
Yes, so this is the reason that we have domain ID in the MariaDB global transaction ID.
Okay, I have a question.
Yes.
So with catalogs, we may have somebody who has a catalog shared by many, on a server shared by many. So we have a replication from on-premise to the catalog. But now we maybe want, and maybe lots of users does the same thing. And now we want to have, maybe the user then wants to have that replicated to another place. So in other words, we need a setting to say that the replication stream only send anything with domain ID 1 forward.
I think we already have that.
Do we have that?
Can you remember, Andre? We do have some replication filters in domain.
Yes, we have.
Yeah, maybe, but we might need to check if the details, because also if it filters on the master or on the slave, I don't remember.
Because we are sending data to
Yes.
other user, we can't send anything that is.
And that's actually, I had a conversation where I forgot who it was. I think maybe that's something we could consider, that some of the filtering could happen, that now can happen on the slave, could also happen on the master. We have this for one filter, which is skip replication, a very simple one, but maybe it should be extended. I think it's a good point.
And on master this time.
This has to be a master because we are sending, we don't want to send everything in a catalog with lots of tenants to another place, so that will get all the data from other users.
Yeah, it's a good point. Yeah. So just to complete this, there's another way so because we have this property, because we needed to have this property that we could have multiple streams from S1 to S2 from multi-source, but we can also do it without. Actually, there's another. Let me take this point first. So when we have multi-source, just old-fashioned multi-source without parallel replication, these two streams replicate in parallel. There's no reason that one should wait for the other. So we also want parallel replication to happen here between S1 and S2. And this is called out-of-order parallel replication. If you set different domain IDs, if you have two transactions that have from different domains, for example, from M1 or M2, they are allowed to replicate in parallel freely without this ordering where one has to wait for it, because there is no order, right? There's no defined order between M1 and M2. But you can also set that explicitly. You can set this GTID domain ID that defines the GTI, the domain for the next transaction that's going to commit. And this way you can specify explicitly as like from the application that this transaction can replicate without constraints against another. You typically use that for long-running alter tables. So if you have an alter table, you know it takes a long time, you can just set a different domain ID and it will replicate in parallel without delaying your slave, the other transaction in the slave.
From the same master, right? From the very same master.
Yeah, from very same. For just one, just like if you didn't have those, just master slave. And I think this is a good. So what is it? This is nice, right? But now we've left this. We violated this fundamental axiom, so this relative correctness doesn't work anymore. So now it's the user's responsibility that this altered table will not conflict with some of the following transactions until it's done. So now we've paid the price of having a no claim leg, but now it's the user's responsibility to make sure it's correct, which is a high cost to pay, right? Yeah.
I figure out also in a mesh cluster with every master connected to every master and using some kind of GODNS. At some point, one of the nodes gets isolated and pass the bin logs. Then this is the only way to recover the GTID is to set domain ID to the missing, because otherwise Step could not reconnect because it's missing the bin logs of GTID.
Yes, yeah.
By making an insert with the new GTID on another node, then the slave will fetch it and it will get the GTID domain ID set to the whole cluster.
Yeah, I'm happy to see. I didn't see you. I'm happy to see you. You're a very good example when I say MariaDB replication is very flexible because you're doing crazy things, but amazing things, right?
Right.
Using this flexibility, which is not possible with some more restrictive synchronous replication. So that's that's a good point. So, but you have to have a high knowledge level of knowledge to understand what you're doing. But if you do that, you can actually do pretty complex things. Yeah, and I think this is something that could be supported better because you need root access to do this currently. To set the. Yeah.
Usually it's because one of the nodes has been.
Then it's fine. Yeah.
Somehow and then.
Yeah. What's time? I think we're done now, right? So, yeah. Skip the slave provisioning. So that was, my point is that we have this fundamental property of having this sequencing which defines it gives us I think this is what gives us the flexibility and the performance and the success basically of MariaDB application. It also implies some limitations, and we still want to try to like lift those, but it requires good thought. It's, and sometimes so if you want to, either we have to, as a developer, be very careful about all the corner cases, or otherwise we're pushing the responsibility to the user, like in out of order parallel application. It's very good for the user to be able to go to that level, but it's harder to use. Yeah, Monty, you want to say something?
You said the Postgres doesn't have that axiom.
Yeah.
So what does that imply?
Yeah. So it was actually from memory, so I didn't mention it, but it's so somebody from Postgres, correct me if I'm wrong. What's it?
There.
So it's at some point I followed the Postgres that implemented serializability in their transaction processing, so that when you run transaction on Postgres, the result is something that could have been. So you run 10 queries in parallel, but it's called isolation, right? It's ACID, it's isolation part, I in ACID, isolation. It means that there is some order in which you could have run the transactions one after the other, and it would have resulted in the same data. And they implemented that. It was not there before, and because they don't have basically shared logs in Postgres and Oracle RDMS, as far as I know. That's the root cause. So they implemented that you had some order, but this order that exists in principle, it doesn't have to be the same order that they actually committed on the master. So you have the property that there's isolation, but you don't know the order that would have given that result. So that's why it's a very, one point, it's a very strong property. But again, it's for statements, not for row events. It's simpler for rows, especially if you have a primary key. Does it make sense?
So Postgres has also statement-based replication.
No, they have both physical and logical. They have statement and they have.
Do they have statement-based replication?
Huh?
Do they have statement-based replication in Postgres?
Yes, they use it for logical replication. They do that. They have both physical.
They have logical replication, which uses row events. It's triggers. You can, for example, you can have a trigger on the table.
Replicate the state, you know, that without Trinity. Yes, basically yes, they have. They have logical replication. That was introduced in 11th, if I'm not mistaken.
Yeah, they do, but it's not based on running SQL statements on the slave. I think it's based on running row event, what would correspond to row events, right?
Okay.
I don't know. I don't know. I don't know much more.
But it's not a physical changes.
I agree. It's a logical, and it makes a big. I mean, many of the advantages as much as said, some would say that row-based replication, logical replication based on the actual row updates and not on the SQL statement is a more sane approach, because there's a lot of tricky code in replication to get statements based to work. Yeah.
It's less human readable, but it's easier to follow.
Yeah, but some users say they need statement-based. One example is if you have a big table and you say delete from table, you delete all the rows. You're going to, Monty told me 100 gigabyte.
And 100 gigabyte statements.
So you have a 100 gigabyte event in your bin log, which is hurtful. Compared to a 10 character SQL statement, right?
Applying it, that takes 1,000 times more time.
Yeah, it's not trivially true that row-based is always better, but yeah.
Yeah, but I didn't get the point whether the Postgres version is good or not, because I didn't get whether it is good to have these long SQL statements or not.
I mean, I think, so in most cases, if you don't have these, so we call it statement-based and row-based. So statement-based means that you lock the actual SQL statement. And it's very hard to make sure that when you run the same SQL on the slave, you get the same results.
Right.
And you can also the SQL statement runs in the master, but it updates these 5 rows. So you pack up the rows, before and after image, and you send that. That's called a row event. And this is still logical replication, but it's much more robust to replicate. And my understanding is that Postgres logical replication uses row events, but I'm not an expert.
Yes,
so,
yes.
Yeah. And that's good. And in most cases, it's better because it's safer, more robust. But in some cases, if you have a small SQL statement on the master that modifies a huge number of rows, then packing up the row events will be like could be multiple gigabytes. So the replication now has to process multiple gigabytes of data instead of just a short SQL string. So in that case, it's hurtful, yes?
Regarding this, when there is a massive update, bulk update on the table, in mixed mode, do you know any condition that will force it to row or
I think in mixed mode, deletes will always be row events.
I mean, there is this, inside the server, there's a lot of logic to identify this query is not safe for statement-based replication. This means that it will either give a warning if you have statement-based, or it will switch to row mode automatically. And does it apply to your bulk update? In general, it's a very complicated question because there's a lot of conditions, and you know, every version we find another, this statement cannot be run safely, so we add more. So hopefully most big bulk updates will use a statement in mixed mode, but in general I would say it's hard to give a general statement. But it's
especially in concurrent transaction, if you have like a big delete and a small delete, then it's possible in committed read to move to log less in the master.
Yeah.
Because of the because it will log as row.
Yeah.
But it's very unclear to me when it goes in statement and when it goes in.
Yeah, and it's because it's
undocumented.
It shouldn't be undocumented, but it's because how was it determined? How was it developed? We started with most things were just statement, and then somebody realized, okay, but if you're doing this, in some cases we cannot make it work in statement-based, so we mark it as unsafe. So there's basically ad hoc. Whenever a bug was found or somebody thought about it, it was modified that this particular case, and it's not, sometimes it's a complicated combination of this and this, then we switch to row mode. But when do we do it? It's something that's evolved, and it doesn't have like it's not something you can write down on one slide, the reason for it. Yeah. So it's a good question, but it's also a hard one to answer.
You need that the replication knows about the transaction.
No,
in a group commit.
No. Yeah, so that's not how it works. So it would be. It's not like the master is analyzing the transactions that are running and trying to understand it. It's not that complicated. It's once that you just look at the SQL statement, you pass it, and then from the nature of the SQL statement, you determine if there's some condition with other transactions where this could be a problem, and if there's any condition like that, you conservatively mark it as. So it could be documented. It's not magic. It could actually be written down. The rules are just complex.
Yeah, it's about
but they're deterministic.
50 lines of code. For example, if there's a limit, I know order by, it's automatically marked. If the engine doesn't support transactions, it's marked. If it doesn't support gap blocks, it's marked, and so on.
The place where somebody disagreed, remember that was about not using resources. So our parallel threads waiting for order to commit.
Mm-hmm.
So this time they just idling these parallel workers, right? Yeah, you
thinking about this figure or?
Yeah. So there maybe was another slide, but
yeah, there was another slide.
They still not using resources. They don't produce any work. I mean.
Yeah.
Actually, they produce work. They are waiting for the turn, and then there's also other things running on the slave than.
There is this chess program, but if
I think there are two things that can be said. I mean, on one hand, I totally agree. This is the main limitation of in-order parallel replication, is that it's in order. So you have all this. I try to mark it with all this line. It's waiting. So, and that is, it would be nice to not have it. But if you want to do things in order, this is actually close to the optimal. I mean, this waiting is, if you want to preserve in order is not just to ensure that you get the same data, it's also to guard against what we call phantom rows. The slave will never see, on the master, you never could see T4 committed and T2 not. That would be a phantom read, and we have the same properties. So you don't have to think of the DBA. Maybe the application will fail if something suddenly it can see T4 too early. That never happens because we commit only at the end. So it's a very good property, but it's really costly also because you have to wait. And that's, but I think one thing that mitigates this is that you can have many threads, right? So you could have, Jean-François Gagné some years ago did a very good benchmark, and he was benchmarking with several thousand threads. And he was seeing scalability of his workload, which was many different sizes. He was seeing it scale up to several thousand threads because it was just filling up this. You can see that this, which had a huge one, was filling all the holes with smaller transactions, and it does scale like that. I think the main problem is that you scale it by having many threads. It would be nice to have some kind of thread pooling so that you could have many transactions, but not 1,000 threads, because that's probably hard for the code. I think that's an optimization that would be very interesting to do.
Actually, a waiting thread doesn't cost much, and the thread costs you basically 2 megs of memory.
And I think that's why it works, right? Yes, I don't know how it would. At least you could measure it if it's yeah. Anything else, or is it time for lunch?
It's
yeah,
time for lunch, guys. This time it's served here for everyone. Please be back after 1 hour. Also, we have very cool t-shirts.
All right, everyone. I tried to go with like a super sexy title for this, and yeah, that's the best I can come up with. At least it rhymes, you know. That's the best I could do. So yeah, contributions. There are loads of different types of contributions. Obviously, there's code. Funding, in the case of kind of the MariaDB Foundation. Documentation is a contribution that's really useful at the moment. We're talking a lot this week how we could improve docs and stuff like that. Community, and by community I mean things like helping users out. If you know how to do SQL and stuff like that, and helping users out on Reddit and Stack Overflow and all those kind of places, there are contributions that are really kind of useful to us. Translations, I kind of grew up in England, so I speak one language only because our education system sucks. So yeah, translating to your local language is really helpful for us. There's a new translation portal we've now released for the MariaDB Foundation, which can help with that kind of thing. And then just using MariaDB and telling us what's good, telling us what's not good, feature requests, bug reports, all those kind of things, they count as contributions as well. And you know, I want to make sure that everyone knows these kind of things are just as valued as being able to code for MariaDB itself. So, as I said, there are loads of different non-code contributions. One sponsor I always pick out when I do this kind of slide is Intel. So Intel is a sponsor of MariaDB Foundation, and it's quite complicated for their internal processes to give code contributions. So instead, when they've got new platforms they're working on and things like that, they will tell us, we've tried MariaDB on this, and you could do these few things to actually make it run a bit faster, and they'll work with Marco and etc. to make those kind of improvements. They run regular benchmarks on MariaDB and try and find areas of the code which are bottlenecks. And due to those kind of things, we've seen some great performance improvements to MariaDB over the past several releases. But today I'm mostly going to be talking about code contributions. So why are they important to us? You can get a much more diverse input, a range of life experiences. So if you spread the code contributions from, say, the US, from England, Finland, Sweden, all these different countries, there's all different life experiences, all different corporate experiences, there's all different use cases. It kind of molds the project into something which can be used by everybody instead of just a small subset of people. And it means the direction of the project is one that's not led by just a corporation, PLC, it's led by the users, which I think is a really good thing. And you get to fix the things that are important to you. You could have something that's important to you, you file a feature request or a bug report, and because it's not important to a corporation in control of a project, it's something that might sit there for years and nothing happens. But you're welcome to, if you're able to do it, you're welcome to contribute that feature or bug or whatever, and it means you can get it into the project a lot quicker. And there's the whole kind of community aspect of it. It's kind of why I do this kind of thing. It's building communities around open source software. So with these kind of things, we gather metrics to figure out the shape of the community, the contributions, etc. Everything I'm going to say here is open source, and in fact you can download the reports, the raw data for the reports from our GitHub releases, and they are published on blog posts, etc. We used a tool called GitDM. I've modified it quite a bit because GitDM stands for Git Data Miner. It was designed with the Linux kernel in mind and generates contribution metrics for them. It didn't quite fit our use case perfectly, so I've improved it in a few places, particularly with the way it generates the CSV files on the output. And it takes a basic configuration, which is a contributor's email address and then what entity they work for, or just independent if they're independent. And it also will track the dates that they worked at certain entities. So a good example is Otto. He worked for the MariaDB Foundation for a while, and now he works for Amazon. So I've got the dates that he worked for those different entities, so it correctly attributes his commits to the right thing. The other thing it does is aliases, which is really smart because For example, when I was at the MariaDB Corporation, I had the email address ahutchings@mariadb.com, andrew.hutchings@mariadb.com, andrew@linuxjedi.co.uk, and a bunch of other email addresses. And also GitHub, if you try and edit a commit in GitHub, it then gives this really long, unique email address as well to your commit. So the aliasing file can actually make sure that all of these different email addresses are just one person in real life. So you don't kind of say it's 10 different people for one contributor. In fact, I had to fix it because Roman has several different email addresses that broke the stats recently. So I tried to keep this up to date, but you're welcome to go to github.com/server/metrics and look at the configuration files and fix them if you can find I've got your name wrong or details wrong in there, because at the moment it's mostly me updating the files every 3 months, and I'm bound to make mistakes at some point. There's good 1,000-odd entries in there, I think, so it's a lot there. Yes?
Where's the affiliation taken from? Like, how do you know?
Where's the information taken from?
Affiliation. The, like, is it someone working?
Oh, affiliation.
Affiliate.
So it's not quite guesswork, it's somewhat guesswork. So what I do is I see a new email address for a contributor. I will research to find out what their GitHub user is. If they've got an affiliation on GitHub, that's the one I'll use. If not, then I might do some research, almost stalking, and look into their LinkedIn.
Big data.
Yeah, and basically try and find if there is an affiliation for them. And usually, like from the commit, you can usually tell whether it's something they did for work or whether it's something they did personally as well, which helps. Also, if it's Google Summer Code student, for example, I know I've been in the Google Summer Code project. I've got the list of people who were Google Summer Code contributors. So I try and manually collate all this to figure it out. There are going to be quite a few mistakes where I've said someone's independent when they're not, because I honestly can't figure it out. And this is actually where I most need help with these configuration files, is just not knowing who certain people are. But I'm pretty sure I've got like all the corporation, the foundation, the bit larger contributors down without any trouble. There are also some other scripts I run every 3 months, which are pull request scripts. So what they do is they talk to the GitHub API, and we'll look at every single pull request that's happened in a given period, and they will categorize it and collate information based on it. So it'll count the number of open pull requests. It does it. I do it in a week grouping. So in a given week, the number of open, number of closed. Sorry, so are you trying? Okay. So it does the open pull requests, closed pull requests, merged pull requests. It also does metrics of pull request handling, such as whether a pull request was merged but wasn't, there was no comments on the pull request before it was merged, which is a bad thing. I'll get to that later on, but there's metrics for that. There are metrics on draft pull requests. There's a whole list of things it collates.
And then two thoughts already. One, do you detect when pull request is stalled, like no activity for a while? So you need to manually do something about it.
Yes, actually, that's the next bullet point. The reports on pull requests that require attention. So actually, there's two things. So in the metrics, there's the number of days, the average number of days between a pull request being open and a first meaningful comment on a pull request by someone who is not the author and someone who is in the committers, whatever the committers group is in GitHub.
Well, metrics are fine. I've seen lots of interesting metrics that just nobody acts upon. So I'm more asking if you actually do something about if you detect and actually do something about pull requests without errors and those kind of things.
So those particular metrics are very new. So at the moment, I'm gathering and not acting on them. Apart from the report section, which I'm starting to act on, the report will generate pull requests that a list of pull requests that are the longest since anyone has ever touched. Yeah. So those ones I'm starting to act on. So it's a new script. It uses the same base code, but it's a script that will say pull requests like 1723 has not been acted on for 1,000 days. Someone should do something about it. So there's that kind of report I generate now, which I think is really useful.
Yeah, another thought I got when you were talking was, well, maybe a good idea to detect stuff that Otto is complaining about, not proper attribution, those kind. I don't know how but you know what I mean.
ChatGPT can take a semantics out of the page and maybe comments, so this way it can be used for categorizing.
Well, I've made it quite easy to process once you've got this when you've got the data from the API to process it. So it's just adding more processing features to it. So there's something we could definitely extend, but the reporting I only added in the last 2 months, so that's all new, and the extended part of the metrics gathering for pull requests is all new as well. So there's a lot it could do, and feel free to open Jira tickets on it in the MDBF Jira, then I can work on them if there's anything extra you think that's needed. But you can see the CSV output files the latest one I'm going to be releasing in the next few days as soon as I actually get time to finish the blog post, and that will be published. Everything's open source, and I say snapshots every 3 months. So the state of contributions that it stands today, this is based on, I actually ran the scripts yesterday, so you got fairly accurate. So we've got 2023 so far, so pretty much first three quarters of 2023. There've been 30 contributors from MariaDB Corporation, 7 for the foundation, and 51 from elsewhere. That's fewer than the whole of 2022 for every category, but at the same time, we've still got another quarter left to go, so I'm expecting them to kind of be similar by the end of the year. Yes?
And maybe that's not, how fewer, but how exactly fewer? Like, what is the number?
Yeah, so PLC is down to 30 from 36. I think there are several factors behind that, particularly around all the changes that happened in the PLC in the last year or so. I haven't dug into that to figure out who's missing and things. The foundation one is an odd one, so there is 8 there instead of 7, and the reason for that is a commit from 2020 created by Otto was merged in 2022. So when he wrote that commit, he worked for the foundation. So it counts as a foundation in 2022 due to the way Git DM processes things, even though he doesn't work for the foundation. So it's a bit of a funny one, and I get why it's like that. But and then you get to see the number of commits, and we're pretty much, I think, on par for, by the end of the year, being almost the same number of commits for PLC. Foundation might be slightly ahead from last year. It's difficult to get a metric that's based on the amount of work done, because I could do lines of code change, but then you could run one script to change 10,000 lines of code, and that's almost no effort. Or you could spend an entire week debugging something that's one line of code change. So it's very difficult to gauge effort done, and so no metric here is going to be perfect on the amount of work done. So I've got also lines added and lines deleted, and that's hard as well, because a commit that changes a line can be a line deleted and line added, or you could delete 1 million lines of code and add no lines. So there's no great way of getting this data at the moment, but it's the best I could do.
I'm curious if we can derive the semantics of the change using either autopilot, LLM, or ChatGPT to just derive the semantics, and using this semantics it is less complicated to understand how hard it is to make a commit, and with that you can come up with a way of the commit.
That could definitely be done. It doesn't actually take long to generate this report at all, so we could add extra code in to do extra processing. It's just time doing it at the moment. So my dream state would be there would be more contributions. We've got more contributors already outside really PLC and Foundation than inside, but it'd be fantastic if we could have more. Yes. Okay.
Is there some that would be also a good criteria to improve.
How would we get the complexity
Well, I don't know. I mean,
That's the hard part. Yeah, I'd love it if we could. I just don't know how to do it. Roman suggested an AI-based system to look at the commits and see complexity based on that.
To derive the complexity in a way
Hmm?
derive the complexity taking the semantics from the LLM model, like throwing the change and asking what is it changing actually, and put some weight based on this extract.
Yeah, we could certainly look into that. At the moment, we do gather lines of code changed and stuff. It's just, if I put all the data on a slide, you won't be able to read it because it's just so much of it.
Well, my point was actually not much about measuring it, but how to increase it, whatever, even if you cannot measure it.
Oh yeah.
I mean, lots of contributors that are just, change one space somewhere or touch.
Oh, I see. Some more complex contributions coming from outside. Yes.
How to improve that?
That is a longer game. That is something I'd love to see. But I think it's more, if we started having a good process of planning features in the open that people can get on board with. I know we do have processes, but they're not well documented to the outside on how to do this kind of stuff. So if people could work with us on planning new features and developing the features themselves, then I think that would open the doors to getting larger contributions. I've spoken to Amazon, and that's the kind of thing they want. They want to contribute bigger stuff, but they're not quite sure how to work with us at the moment. I've been trying to talk them through it, but we really need something hard documented for that.
Did you see from Amazon's side that they discussed actively the feature before creating a pull request?
They do not at the moment. They should, but I mean, there are sometimes they do in the MDev beforehand, but I think they could. There could be a better way, and I think it's something we need to discuss and figure out. But so I'd love to see more contributions. Eventually, some decision making about what goes in and what doesn't, made by people outside of MariaDB. Yes.
Yeah. So while we're at it, do you know any other open source projects that do this kind of stuff? And if you do, then is there something that they do that is not mentioned here, or that is something that you feel is easily implemented in a reasonable?
That's a loaded question. So yes, I can. I've worked for quite a few open source projects that do things very differently, and there are things we can change in MariaDB, but it's not a quick fix, if you know what I mean. Okay. Over time, I will hopefully be finding ways of implementing good process changes like that in ways that will keep Sergey and Monty and everyone happy as well. So we will figure out a balance eventually. But first of all, the first step is to properly document in like a governance file or something, the way things are right now, and then we can look at how things could change in the future, essentially. That's something we can look into. But for now, it's a bit of a different. But you gotta remember, like MariaDB has got decades of legacy behind it, where the developers are used to doing things a certain way as well. So change is very difficult in that respect. But we've got great strides. We're using GitHub now, where we were using Bazaar for a while on Launchpad, and then before that it was BitKeeper, I think, and a few other things. So more modern tools are coming in, and I think that's always a good thing.
Did you look into what kernel, for example, are doing, how Postgres?
Yes.
They have at least three heads.
Yes.
Driving the.
Yeah, one of my slides mentions Postgres somewhere, but yes, it's kind of out of scope for this talk because of the time. But yes, I have looked into other projects and trying to. There's no one model that fits every project perfectly, but there's, every project can do better. So I mean, how contributions work kind of right now is. Assuming everything's planned and everything, a pull request is opened by the contributor and it's usually attached to a Jira ticket. If not, it should be attached to a Jira ticket. There's a bot called CLA Assistant, and that checks for a signed CLA by the contributor. So if you don't know what CLA is, it's a contributing license agreement, and it essentially signs the copyright for the code over to MariaDB. Alternatively, you can contribute using a 3-clause BSD license if you're not comfortable with CLAs. I know a lot of people aren't. And that process can be improved a little bit. The CLA system we're using at the moment is not great. It's a bit buggy, and if you want to declare BSD, you have to go as if you're signing a CLA and then choose BSD right at the end before you sign it. So it's a bit of an odd process, but we can definitely improve there. The pull requests run in new build bots. Some of the reporters will automatically report back to GitHub. Some of them don't at the moment. I would want to improve that situation. It's just I also don't want 200 entries in GitHub saying that this was checked by this builder and this was checked. So we haven't come up with a happy medium for that yet. So it's just at the moment the most important ones are blockers. And some of them are not blockers but report, and then some don't report at all. We have to actually go into BuildBot and find the state of them. But that's something we're working on. It's getting better all the time, but there's still some work to do there. And then a reviewer will review the code, and if it's good, it's in the right place and everything, it meets everyone's checks, it will get merged into the code base. How to improve? A lot of these things have come up this week already, but I'd love it if we had the same process regardless of whether you're a corporation developer, PLC developer, or a community developer, a Google Summer Code student, whatever. I'd love the process of code being reviewed out in the open the same regardless. I'd love open discussion on features, and I mentioned Postgres there. The way they do it is essentially a feature request is declared on a mailing list, and if once that's discussed, it's approved, then there's a wiki page that's created where the progress of that is kind of tracked and everything. And there's a lot of good process behind that. I'm not quite sure when the tooling is right for us, but the process is good, I think. I'd love it if we had 2 core reviewers to approve code. Again, this is something else I've mentioned this week. And this is something we can actually do quite easy, that when the code has been approved, GitHub can just automatically, and the CI has passed as well, GitHub can automatically merge it. So this is a step we could take, and we've discussed with Daniel, we might do this at some point quite soon. So I'm not quite sure how this graph's going to come out because it's quite tight, but this is just 2 of the metrics I get for pull requests. So the red line here is the number of still open pull requests per week, and we hover roughly around the 150 mark, which is not a good place to be in. And it's my job to get that down, and it's been slowly going up. So yeah, that's I need to fix that. The blue line is the number of new pull requests per week here. So that hovers somewhere in the region of 10 to 20 a week of new ones coming in. So we're kind of keeping a rough balance of new ones coming in and being closed, but not getting rid of too many of the old legacy ones. That's something I've been trying to work on roughly when that dip happened. But it's a lot of work to do that, and it'll be a long way before we can actually get that down to the bottom. Pull requests for 2023 to date. So there have been 24 pull requests merged without any public review whatsoever. And what that means is the author opened the pull request. There was no comment by anyone with authority on the pull request, and then it was merged by that author. There are 24 of them have happened in the last year. That's a bad thing, so we need to fix that.
Do you count all pull requests or only pull requests by external people without right access to the source code?
That particular metric is internal people. So each one of these metrics filters in a slightly different way, but that one filters on people who have commit rights, who have opened a pull request, there's been no public comment, and it's been merged by that same person. So not an ideal situation because we don't know why they did it, and it could be a process abuse. It could also be that the thing was reviewed outside of GitHub, but at least needs to be a comment saying, hey, this was reviewed outside of GitHub, because otherwise. But I know who it is, and they have been spoken to about it, and hopefully that will stop happening. But now we have the metrics to show that this has been happening, and we can fix these kind of things. The average days to first meaningful response. Now, this is a tricky metric to get. The way we are counting a meaningful response at the moment is a pull request is opened, and then someone who isn't the author, who has commit rights, has either commented or submitted a review on the pull request. So the time between those two dates is what we call a meaningful response. That doesn't mean the response was actually meaningful at all. It's just very hard in an automated way, given how much processing time is just to generate that metric, to actually get that right. Yes?
Yeah, I would suspect that the average here is not really, not a good sort of,
So the raw CSV data has the real spiky stuff in it, which shows.
That's what I'm saying. There are real spikes. And so median.
I can do. It's just a CSV file, so you can just generate the medians from the CSV. I just haven't done it. Yeah, no, it's a good point though.
90 would be better. 90 to 75%.
So we have some in there that have get responded on like within a day, so almost like 0 days, and then you get some that don't get responded on for 1,000 days. So there are some real spikes like that.
Just the distribution.
I'm sorry?
The distribution actually, I mean, if an hour really goes to...
Yeah. Again, I was trying to fit something on this slide that, if I put the raw data on here, there's no way you'd be able to see it because it's just,
I'm curious if you compare these metrics with other projects. I'm curious if it's possible to get the...
I do not at this time. That is a good point, though. We should do that. So the number of new pull requests so far this year is 376, and the number closed is 346. So there's actually only about a 30 difference between the two. And that is everything I had. We are on time. We've got a couple of minutes if anyone's got any questions. All right, thank you very much, everyone.
That was fast.
It was fun. It was half an hour talk, and I was bang on.
Okay, so ready? Yes, I'm here again, if you were here for the first talk. So this is a short talk of a feature that I'm implementing, a fix for an old performance regression in replication from global transaction ID. And again, I'm Christian Nielsen. I'm a long-term MySQL developer and implement a lot of replication features, and long-time free software developer and also independent consultant. So the problem here is when the slave connects to the master, how long does it take? So what happens when the slave connects to the master? We had before global transaction ID, it was very simple. The bin log consists of different files, called like this. And the position on the slave, you would say, I want to continue replication from this file at this offset into the file. So we have like the GTIDs in the file, and we have some position. So that's very easy for the master to start the slave replicating. You open the file, and you see to the number, and that's fast. And then you start sending the events. All good. And then we implemented global transaction ID. And global transaction ID is now not, we don't identify, I mean, it's a kind of this identifier which is not directly related to the data on the master. And it's even not just necessarily just one position, it can be multiple positions related to multi-sort and so on. I talked about that in another talk. So how do we find the place to start? Well, the easy answer is we start from the start of the file, and then we scan until we find the right position. And that's how it was implemented first, so we could release. And works fine. It's the bin log files is 1 GB default size, so it's slow. And of course, I realized this, that it was not the best solution, so I filed the MDEL for this, and I was looking in the summer, and I just wanted to share my kind of dismay because it's 10 years ago. So sorry for 10 years of performance regression, but at least I'm fixing it now. Sometimes that happens, I guess. Yes, but so what's the solution? So this problem is that we have to scan the bin log like serially, and we don't want to do that, so we will make an index, which allows us to quickly look up in the index. You have a GTID position, what is the corresponding place in the bin log to start. And so this is from the implementation I have now. You see the normal bin log files as an extra file written, and you can see it's quite small. Typically it's like 0.3%, so the space overhead is very moderate. And you can look up the GTID position and find the place to start. You can also go the other way, and this is actually used for when you connect. So when the slave connects, like after an upgrade, it connects with the old style position, but GTID then finds the corresponding GTID position. Why does it do that? It's not necessary, no, but that makes it trivial for the user to switch to GTID. Because it already knows the position. So that's an upgrade feature, but it costs for, so yeah.
Overhead, could you explain just briefly the overhead?
Yes, so you see, before we had only this master bin .1, .2, we had only the bin log files, and they have size of 1 GB. But we now create an extra file, and it has a size of 3 megabytes. So we are using extra space, but it's only 0.3%. I mean, it depends, but it's something like that, an order. So I think that's very reasonable for fixing this. We only spend 1.3% more space. You can actually also adjust this, but I think 0.3% is fine. So this is my proposed solution, and so I did some benchmark, and just to see for the prototype implementation. So what we do here is I ran a suspense write only just to have some data, wrote some bin log files, default size 1 GB. With this benchmark, there's approximately a bit more than 1 million transactions in each bin log file. So we have to scan at most up to 1 million or 1.3 million. And I tried to time how long does it take for the slave to connect to the master and replicate one transaction in GTID mode. In 10.11, and in using this new implementation with the GTI index, starting at different positions. If you start at the start of the bin log file, it's fast. And you can have different places. And what we see is that before it increases linearly, right, it gets up to 1 second around. So don't take these numbers, the absolute numbers, too literally. It's running on my laptop, everything is in memory, there's no encryption. Yes, Sergey?
Can you also benchmark how long it takes to write the overhead of maintaining the...
Yes, I'll come back to that. That's very little overhead, but it's a good point. So yes, so you see with the index it's basically independent because the overhead of looking up at the index it disappears compared to the other overhead of connecting. So that's a good result.
The number of read operations, of course, depends on the size of your transactions. So the smaller transactions, the more reads, and therefore...
Yeah, so this would be slower, but this would not.
Yes.
Yes. Oh, sorry. The other direction, looking up, you have the position and you want to find the corresponding DTID to switch to DTID's position at time that, there's a function, DTID binlog pos. It does this lookup. And you can see how dramatic, so this only does the lookup. It doesn't do the overhead of the slave operation. You can see that it's very fast to look up at the DTI index, right? It's very quickly and it's, of course, very fast. It's just, of course, you have to scan 1 million DTIDs or you look up at an index. This, of course, the faster. But this is also solved. So this solves the performance regression for the slave that's not using DTID, which is, in a sense, worse, right? It's a regression for existing, but it's 10 years ago. Yes, so the benchmark looked good.
The left column is physical file position. The left.
Yes, so this is different places in the binlog position. So it takes, to scan to the 80% mark of the binlog, so 800 megabytes, and find the corresponding DTID position, it's actually only 0.3 seconds on my laptop. So it is fast, actually. So that's probably why people have been able to live with it for 10 years. But it's still an issue, I think, because imagine the master shut down and then it comes back up and it has 20 slaves. They're all going to do this.
Yeah.
And actually it's more expensive here, right? They're all going to do this. And what if it's encrypted? You have to decrypt it, yes?
Why do you need to scan the binlog if you know the offset?
Yeah, so maybe I should elaborate on that. So you don't need it for the slave, but it was implemented to do it anyway, and the reason for that is that it allows you, if you're on 5.5 or something, when was it? Before 10.0, before DTID, you have an installation, then you upgrade to 10.0, and now you want to switch to DTID. You just start the slave in non-DTID mode, then you stop it, and at that point it has downloaded the new DTID position. Then you just say change master to master use DTID equals to slave pos, and then you start it. You don't have to do any other migration. So it was a usability function to automatically find the DTID position when you upgrade to use DTID, or later.
And so the function would run on the master.
Yes, so the slave will ask the artist to run this function on the master, and it will return the result. And that's also expensive. So the regression is not just for DTID slaves, but also for non-DTID. Okay. So this is how it's implemented. I'm using a B+ tree. It's a classic structure to do on-disk indexes. The keys are pairs of the DTID position and the binlog position. They sort the same way. They follow one or the other. So you can look up a GTID and get the binlog position. You can also look up the position and get the GTID. If the index is missing because it was an upgrade.
You're saying you implemented both ways?
Yes, it's kind of they follow. I mean, the order is the kind of one-to-one correspondence, and the order is the same. So that's why you kind of have dual key. Mm-hmm. Yeah, it's a modified B-tree structure. Yeah, if the index is not there, if an upgrade, or if there is some, the DBA removed it, or you can fall back to the old method. So it's not critical. You don't break replication if the index is not there. It's much simpler to do this than a full B-tree implementation because the binlog is always just written serially, and the order of the keys is the same. So you never have to split a node or do anything. It's just you're just appending to the tree. So it's maybe more like a log-structured merge tree if you're familiar with those, but there's no need for merges because the binlog files have a fixed size, and then you write a new one. So it's much simpler implementation, and the way it actually works is now I've tried to write the tree just how it's written. You just start writing out putting nodes in the memory buffer, and once you fill our lead page, you just flush it to disk, and then you put a record in the next level. And when that's full, you flush that to disk, and it's so that it makes the implementation relatively simple. It's page-based. It's an advantage. I mean, you write one page at a time. That's very good because it makes it easier to read it. You can just seek to the end of the file. You know where the end is of the page, and then you can see if that's not there, then the page's index is partially written. You have to recover it. It's using crash recovery along with the bin log file. So if you crash, then you recover the bin log, and while you recover the bin log, you reconstruct the index. So they crash safe. Yeah. I had a slide. Yes, so again, you asked about the overhead. And I think it's a valid, you have to, when you do the GTID, you're running under this lock _lock, the bin log, which is highly contended. So you don't want to like flush out disk, do IO to the index if you can avoid it. And that's why I implemented an asynchronous code path. So the only thing you do is that you send the record, you send it to the bin log background thread, and it will write the index in the background. So it happens in a separate thread. So that's why it has minimal impact on bin log performance. Would be interesting to measure, of course. And you don't have a lot of overhead while you do this.
And it starts working when this bin log checkpoint events, or the bin log background thread when it does this work.
Yes, but yes, it uses the same thread. So the bin log, the same thread. It was used before. It was only doing checkpoints. Now it's also doing this, but it's you do this for every transaction, or actually for every you can have it sparse. So like I'll implement it so that it's for every 10 transactions you will flush, because there's a little point in, it doesn't really matter. It's no point in searching for like the exact GTID because in the index, because you anyway have to. I mean, you can just as well scan 10 GTIDs in the bin log file as in the index. It's about the same. But it's configurable, or it will be configurable. Yeah. Mm-hmm. So I think time is out. So they are using prefix compression to reduce the size, but it's a technical detail. You can ask me afterwards. That's what's about this. You could write only. You can. It's sparse, so you can write every 10th, one in every 10 GTID. Yes, so it's. I have a working implementation. It needs some cleanup. I also also need to make the user interface for the configuration and testing, but also really, if somebody is interested in working with me or having this or reviewing it or using it, then let me know. And hopefully, I'm not sure, 10.3, 10.4, it sounds like 10.4, maybe there's a 6. Yeah. Yes, so that's it. Questions?
What's about the last bullet?
This one? Yeah, so I mentioned briefly that this index is page-based, so it means that you write it out in pages, like 4K pages. Every node is a 4K page. And the bin log doesn't have that property. The bin log, you just have, it's a flat file, not a text file, but it's actually event by event. So it doesn't have any structure apart from a flat, it's just a flat file. And that that gives some problems, because why do we even have to do this? If the bin log was page-based, we could do binary searching. We could like search to the middle. We want to search to the middle of the bin log. Is this the right place? Or is it too far? And then we could do. But we cannot do that, because if we go to the middle of the bin log, we don't know if it's the start of an event, or if it's something that looks like an event, but really it was a blob insert. So you cannot, the only way you can do anything with a bin log file is to read it serially from the start. And that's a limitation. So, but it's a kind of crazy, wild, long-term idea. Could we have just one file instead of having this extra index? Could the bin log file be made into a better, more mature log implementation where you have a page-based and you can have the index within the file. It's an idea for that.
Right, but you already have this parsing that allows you to somehow get to the middle of the index, right?
No, I mean, with the index?
No, you have a sparse index that points to every end.
Yeah, so with the index I can do it. Yeah, but it would maybe be better if we only had the index and then had the data in the index, like cluster
I just
index.
don't see how would you utilize the fact that bin log records are page organized. That's what I'm talking about.
Yeah.
When you saw that the potential use case would be to use a binary search, basically to be able to build a tree to arrive at a certain page, you have a sparse index already.
Yeah, maybe that's probably, yeah, it's maybe.
Use cases.
I don't have a particular, I don't have a particular. I just remember that I had sometimes this way the bin log. It's also just whenever you're writing, actually that's one case. So whenever you're writing a new event to the bin log, say a 100-byte event, you're extending the length of the file. It's a file that's to the operating system, it's appending. So the file was 10K long, and now it's 10K and 100 bytes long. So then you sync the f-sync the file because you need to make it durable. And that requires the operating system to first sync the data to disk. But then the metadata, the length of the file, which is somewhere else, it also has to be synced to disk. So it's a double cost of writing to the disk when you have a file that's being all the time increasing the length. If you have a page-based log, you can pre-allocate it, and then you can just write just the data. And because it's a page-based, you can detect that the data, the extra space, you have around 100 bytes, but there's 500 more bytes. But you know, because it's page-based, you can see that it's empty space and not the middle of a blob. So that's one reason.
You don't need page-based for that. You just reallocate 10 gigabytes of numbers writing. And
then detect it by having zeros.
If at the beginning of the event header or it's
a zero, yeah, maybe that's if you're sure that no event can start with a lot of zeros. It's probably true. Yeah. Just the type. If the type is zero or missing, yeah, maybe that's a good way to do it. Maybe that's an easy way to do it. Yeah, good point. Yeah.
So mine bin log is binary file, not for example InnoDB data.
Yeah, it's so there are different reasons for that. One critical reason is that when do you allocate the GTID? The GTID is written into the transaction at the start, and the GTIDs have to be monotonically increasing, and they have to be increasing in the same order as the InnoDB sequence numbers in redo log, so that you can do a consistent backup. I can explain that more after maybe. So you have to have the bin log, the InnoDB commit order inside InnoDB has to be the same as the bin log commit order. But the problem is that first you have to prepare the transaction inside InnoDB, then you allocate the GTID, and you write the bin log record, and then you commit inside InnoDB. But that means that you first prepare the InnoDB transaction, and now you allocated the GTID. But now you can no longer put the GTID inside the transaction for the table inside InnoDB because you already prepared and closed the transaction. So that's one reason.
Yeah. There is a performance for that approach, and negatively, that time, 10 years, cost of writing to a table.
Yes.
Yeah.
You checked that in MySQL or benchmarked it?
Yeah.
Yes. And it was a big overhead, right?
It was rather big.
Okay. Yeah. So that's another reason. Okay.
Show bin log events to exploit that. Your ingenious work.
Yeah, you could make sure bin log events use it from. How do you mean?
I forgot now. Do we have GTID as an argument to find events starting from?
Maybe, but we could have it now.
Plus, and MySQL bin log 2 to use these indexes. It doesn't. You did do this.
Yes. Yeah. Brandon actually mentioned that, so that's a good point. Yeah. Okay. Anything else? Thanks for listening.
for him.
Socket.
Так же стоит здесь.
Смотрите. Thanks everybody for coming. Otherwise I will forget to do that. My name is Andrei Elkin. Together with my comrade Brandon Nesterenko of replication team, we're presenting just very hot subject. I'm just really from the field of making this work, so bear with me with the slides. Oh yes. Thanks. This one go? Okay. So, to repeat, Andrei Elkin, Brandon Nesterenko, we present XA transaction replication and performance improvement on the parallel slave. That was already presented before what this parallel slave is about. I'm focusing on specific way of making transactions. So what is XA you can find in documents like here on the bottom line specification. But in our ordinary life, every one of us is aware of actually what is this XA, just in plain human life. Here is a case that depicts it. Someone's need money, but because money on the shared account, this one politely calls the shareholder and asks, like, if, well, whatever language, maybe not programming is here, is used, but prepare for that. There would be a reply, yes or no. That's not enough to get money from the bank. With the bank, basically, would be the same. Repeat of this request, prepare, give me this cash, and the bank could say, of course, that I don't have cash now, but say tomorrow you will come. So that reply, positive reply, is okay to the preparer. After that, yeah, you come to the bank. Here, maybe you don't need to call the husband, or whoever it is. And things are done. There could be various failures along this rather simple process. Nothing will be printed out of this ATM machine. So this is real life situation actually was standardized for programming in this specification, the XA specification. So it is, in other words, a way to conduct two-phase commit
with various resources which are not necessarily programming units. Could be ATM machine itself, could be human actors, could be, yeah, whatever. So let's look into the closer. Okay. So if we look into the fast forward to the computing part of the this transaction, what's happening with this actor? Yeah, the human actor on the previous page, the blue figure. When it comes to execute that, say, financial transaction in the on the database system, the database reflects sort of situation in the bank. Transaction is started. It's you see XA start, but it's practically with the remembering the previous slide, it would be a branch of that mega transaction that involves people and other things. So, but in our branch, we're actually dealing with branches. You will see how it all breaks into more branches soon. So, but syntax for this operation of initiating transaction is XA start, then updates, maybe decrementing on that account. Then XA prepare, I didn't write XA, but syntactically I should. You see also, I tried to depict TR stands for the table, that's sequence diagram, of course, and TRX stands for transaction, in a DB transaction specifically, in my mind at least. So you see for the table, this InnoDB handler would be invoked with HA update row. So if we just update one record, that would be enough. OK to it, gets back, and let us see what on the next slide we'll have. A bit more detailed view. So you see OK will probably get back to the user. And now I involve that, start involving more resources. You see that how branches appear in this replicated system, master and slave. So master, of course, in this case has been log, and bin log receives prepared image of the transaction. It's not the whole transaction, not committed one that is, but intended to be committed. This is actually interesting thing that we touched along this morning already on few occasions. But it's maybe too early to generalize it for you, but I will mention now synchronous replication at this point. It's very suggestive. Yeah, let's see next transitions. So now I'm adding the slave server to on the picture. You see after writing to binlog, transaction gets to the slave, and once it occurs sorry, my French, it is in prepared state on slave, but not executed, but still in prepared. So we can expand it on slave when we will have this time. And normally, and how it was actually done, this work is based on XA replication framework introduced a couple of years ago. So execution of that prepared state transaction becomes at once, and in parallel maybe with other prepared transactions, or with prepared and just normal transactions, that is begin commit. They could, of course, conflict, as in optimistic mode happens on the parallel slave, and that ensues temporary rollback. Usually if conflicts occurs, it could be like transaction in binlog later, yeah, say time is downward. So it could raise first to get lock on the data. Then early transaction in time hits that lock and can't move on, but it is first to do its work. So I'm now explaining how parallel optimistic mode works. It will kick off that
kick out this offender, but not error out after that, but it will be replayed, the victim of this conflict resolution. So this also applies to prepared transactions. So we now are officially adding the slave branch of the prepared itself transaction or branch. So it just you see transitive relation here. XA preparer creates prepared transaction on master. When it's replicated, it reaches the orange S slave, and from it, user can now invoke something like XA recover, and it would receive back seed of that transaction. That means this transaction now is available on few queryable from 2 resources and can be completed from either side. That's, of course, is about high availability of this transaction. If we lose master, slave can be the holder of that information that user needs. Yeah, so I said that we replicate prepare. Of course, later the user would say XA commit or XA rollback. So we replicate that statement separately. It comes to binlock with its own GTID. So like XA transaction is presented in binlock with 2 GTIDs. XIT of the prepared transaction of XA transaction identifies it. Interestingly, maybe it's a detail, but worth to mention anyway, that it's not supposed to be unique. When XA transaction fully committed, that user, another user can issue namesake XA, and yeah, it will run. It will have, although GTID generated with sequence number, of course, higher than before, one of before. Here, so I spoke that, I said that that XA preparer will be run in parallel at once. When it's not in normal configuration, in default configuration. When receiver thread works, applier threads works. Say we have K, so I'm just trying to abstract number of workers. Each of them has this Q in capital 1 to K Qs. Yeah, they are depicted vertically. You see from binlock, it's another server, so binlock. We have this running up the time, of course, because yeah, J stands for GTID, just name of transactions. They are coming. Normally, now I'm speaking about normal transactions case. So this round robin is a good method. That's, by the way, what Christian's works is of this optimistic parallel slave I'm explaining. And it's important to see what I'm trying to solve. It's a big introduction. So we have, you see, workers receiving transactions one after another, just like, as if they enumerated these worker threads. And we can say in that what is the index of GTID for each worker. Yeah, you see the row, yeah, the horizontally placed row, which I wanted to designate with it that transactions, if they were of the same size, they would be committed as this one whole row of transactions. So K at once. That would be ideal picture. If transactions of the same size, workers work with the same pace, then everything will be kind of group committed. And so you can think that ideally performance of the slave is like executing one row after another. It's like coming upward, yeah, consuming what actually comes to those threads, which are circles. And yeah, we have this condition to commit. I mentioned this conflict resolution thing. Yeah, you see that preceding transaction is a kind of parent for the follower, immediate follower here. K plus 1 depends on transaction K. That is, if there will be conflict between them, the later one, k plus 1, will be victim, will be removed out of sight. GK will be committed. After that, GK plus 1 will make another try. Worst case to wait here. Worst wait to commit. So it's not obvious, and I will not dwell into it, but it is always constrained with this formula. So at any point of time, there could exist not more than, you see, two, we should subtract 2k minus 1 transactions. So that's a hard limit. But in case of XA, because I mentioned you this seed also, that it's not unique, it could be reused. Decision to replicate, to apply on the parallel slave was not to distribute them in round robin, because we wanted what? In this diagram, so orange boxes are replication threads, worker threads. They could receive, you see, say XA start with that seed, literally. Later, idea was that the very same worker would receive also commit, XA commit with that seed. That it would be it executing both parts, and we may not be scared about what to do if this, say, yet another after this transaction, XA start with the same, very same XIT occurs, but we run optimistically, then conflict would be not about data, but about XIT. So how to handle that? So in order to not mess with this part, decision was simple. Okay, let's just hash the XIT, which is 128 bits, into 32-bit number, and having so many workers as we have, we can distribute same XIT necessarily to one worker, and maybe some other XITs, of course, will fall into the very same worker. I just said this, XA start X, Y, Z. And you remember the previous slides is full, dense, contained. All the boxes were contained. They all were marked with green, so they're busy. In this way of depicting private queues, like so, in this case of existing in 10.6 and on XA running parallel slave workers, they would have empty boxes if we distribute this hash weight. Emptiness means that roughly that at one kind of step of parallel execution, there will be here executed just 2 transactions. Next row, there will be executed 5 transactions. So you compare with the previous, it was k, all k in one step. You see also worst wait to commit. At any point of time, in system, the number of executed transactions, the range could be, actually we cannot find this I at all. It is, it's property of maybe hash function. I didn't try to do any math with it, but it's unconstrained practically. And you can see that in statistics we collected, here is some opaque maybe, in statistic messages I collected. So it's a 10.6 without any changes, and 8 workers situation. And what we have, when I computed here these numbers, starting from the second line, how many times it was a situation that this transaction, when it starts executing, it was just next the first figure. It was next to the last committed. Second figure, the distance between them were 2, from the last committed to the being started one, and so on. Remember, we have 8 workers here, but you see how many transactions could be Yeah, so each index, that means one step to the distance. So that this is really commit distance. And it's 100 numbers here. So with 8 workers, we can reach this 98.
It's like a histogram.
Sorry?
Is it like a histogram?
Well, perhaps it's for me it was enough to guess the reason of slowness in the system. So I just counted why we have, this show process list who uses parallel replication, of course is aware of that, waiting for prior commit. It can last, and it can last like in your, once a second you do this, and some other worker will report that now it is waiting, and so on. So, and I try to enumerate this state. Yeah, but what you're waiting for? What happened when you starting waiting? So there were so many transactions not committed. In the normal round robin case, it would be 15 at most. And here we see that we can have 89 easily. Second, basically, warning is something about this. It's just at time of committing, similar situation, but at time of committing. When transaction is committing, I also was concerned to see how many transactions are not committed yet before. So the same thing. Predominantly, you see that transaction being committed, waited, just one. That is 1132, that is 1100 something. That's basically what it preferred to see. But anyway, it could reach also those 99 before it. Not often, but sometimes. And that was enough to have degraded performance, which now I'm coming to the this easy stuff, pictures. This is, well, you maybe by shapes can understand what's going on here. Blue line is a 10.6 bar without our fixes line. It shows some scalability, and what's the load here? It's you see vertically insert delete, and the second part of the graph is update operations in the transaction. So blue is bad. That was something that we wanted to improve, and we quite succeeded, as you see. So the bluish, this or greenish rather, and yellow correspond to configuration of slave with logging in binary log and without. So yellow must be, I'm incorrect about it. Well, let's switch to another picture. You will see explanation here again. So it's actually non-XA. Yellow corresponds to XA, just normal transactions, how they compare against, here is reference to the MDEF that we worked with on green line. And XA is more costly because at prepare and at commit they require fsync operation normally in order to them to be available. After I can estimate like we gained with on the horizontal line, of course, number of threads, vertically transactions per second. So improvement was 3-4 times with this specific load and this specific CPU. It was, if I remember correctly, 16 dual core computer. Yeah, so round robin, it's the concluding picture, also showing the dark blue is almost violet, is about base, unfixed base. Yellow is when slave bin locks, and green when it does not. And green is a bit better, how it's supposed to be. And on the left, yeah, I was commenting rather on the right hand side. On the left hand side, we're having on the master. Yeah, our change is done to the slave side, to the applier. So master did not really change. What else to say? Before I will thank everybody who employed his intellect, his will, his those people deserve me to thank them. References. The first is MDEF, which describes the framework of XA replication. It's done in Oracle originally, MySQL Oracle, by myself, and was integrated into MariaDB, also by well, myself too. Yeah, the XA transactions, we could find something on our documentation pages, knowledge base, and I mentioned this distributed transaction, this specification document. Who is interested doing some work, so we could look into that. Where we can go with this? Yeah, I mentioned this synchronous replication. That's a very productive, very generic solution, actually. We don't need to prepare a transaction in order to replicate it. So in a synchronous replication, we even commit it. After that, we replicate. Now the system is really synchronous with XA, at least. XA can be found elsewhere, not committed, in non-committed form. So that means synchrony, of course. So you can throw away one computer, take another one, and to the specification, it allows for extending this transaction in a way of joining, suspending at any time. You don't need to prepare it. You can have it half done, 1/3 done, then you replicate this part. That's my plan. I'm not sure if it will materialize, but I'm very keen to do this work. So with this framework, when we expand XA's syntax, and we have this two-phase logging mechanism already in place, we can easily generalize it to be 3-phase, 4-phase, as many can be configured. So these parts of transaction can be delivered piece by piece, maybe query by query, join that XA which was started, initially on the slave. And at any time you can remove this computer, you can lose it, but transaction will be with you, even not as prepared. So that's great property to me, and I'm saying that it's very feasible to implement. That's kind of huge. Now, if you have any questions.
What XA stands for? X, I mean exclusive, but A. What is the meaning of the acronym?
The acronym, extended what?
No, exclusive, I suppose, or extended.
Extended.
Right.
I forgot this is extended. Guys, help me in Wikipedia to find this.
Do you think that this property that you mentioned, having them multi-phase repeats, might improve the consensuses, the existing consensus protocols, like delivering a partial transaction to other nodes?
Yes. That's the idea. We can replicate partial transactions with any granularity using the XA specification if it's implemented, extended from what we currently have.
So we can partially replicate a lengthy transaction. So when its turn happens, we can apply it faster.
comparing to what we would do, waiting for the previous transaction to be delivered, to finish its two-phase commit?
Yeah, we can start applying before other concurrent on the master transactions have committed. And because we have this also optimistic framework in place, we can sort out conflicts. We can kick out the offender, which came overly optimistic. Yeah, so this partial transaction can indeed hit some conflicts. Even though on master it's not. It can be safe on master, can be parallel on master. But on slave it could suddenly start conflicting. But for that we have in place solution. We're only missing from really, to be really synchronous, we're missing extension to XA, which is described in the specification. We're missing implementation of some of those things. I'm missing, of course, decision to do that.
That makes sense. I mean, I understand why it wasn't made such decision. There is a product.
Yes.
A specific product that does it. Okay. Thank you.
Yeah. Thanks, guys. Let be a UITM machine always full of what that was depicted on the first slide. Okay, well, what should I do?
Hi everyone, my name is Jiayu. I'm from Huawei Cloud and I'm working on Taurus right now. I'm sorry I cannot get to the scene. This video is recorded in advance. Though I'm not aware of the detail of others' topics now, I do believe they are very wonderful and professional. As a database newcomer, I'd like to share some of my learning journey. Today I want to share with you a simple, small, but really interesting topic, internal temporary table. The whole story starts with a strange phenomenon. A customer complained to us why his circle can be executed properly on old version of MySQL 8 and MySQL 5.7. But got really slow on MySQL 8.0.29. After analyzing, we found out that the problem is caused by timetable engine. There was a bug that made the timetable engine perform too many memory allocations and release. After the problem was located, I was curious why we need timetable since there is heap engine already. What's the difference between them? To answer the above question, we have to know some basic stuff. The first is, what is internal table? In some cases, the server creates internal tables, will process statements. Users cannot view it or control it when it occurs. And when will internal temporary tables be used? There are many cases, such as derived tables, common table expressions, also known as CTE, and in some cases, subquery and semi-join materialization will use internal temporary tables, and distinct statement combined with order by will use the internal temporary tables. And in this example, it's a nested select circle statement. And we can use the explain statement to show its execution plan. And we can see the extra field, there is using temporary, which means this circle will use the internal temporary table. And the last one is which tables can be used as internal temporary tables. First, heap engine. Heap engine is a classic memory engine, and it's supported by MariaDB and MySQL both. It has been used very long time and it's very stable. And the second one is timetable. It is a new engine only supported by MySQL 8. And the last one is InnoDB. InnoDB is the bottom line solution. Although InnoDB can ignore the memory size and solve all internal temporary table scenarios, its efficiency is greatly reduced when disk I/O is involved. Internal temporary tables are usually used in the query process. The most important factor is efficiency. And the heap engine and the timetable engine are both memory-based engines, which means memory engine-based engines are one or even several orders in magnitude faster than InnoDB in terms of efficiency. So in most cases, we want internal temporary tables not to use InnoDB. And in this share, we just focus on timetable and heap engine. And timetable has become the default internal temporary table for my Circle 8. And as an internal temporary table, most operations are insert, update, and read. And with the help of our customers, I did some tests based on their scenario. Queries through the derived table, and the data records are short and simple. It's not a sufficient test, but we can tell the difference. We can tell there are roughly 32% performance improvement for timetable by or against a heap engine. But based on this, can we just say timetable engine is better than heap engine? And now we can see there is a constraint we didn't mention before. We did a test under sufficient memory, but for most cases during the service or the server, there are memory is always expensive and rare. It always not a sufficient resource. So we need to know how many memory do the two storage engines use. We can see under the 4 million record insertion scenario, heap engine only takes up less than 300 megabytes, but timetable takes up to more than 4 gigabytes. That's 15 to 28 times memory deterioration. But why? To understand why this happened, we need to know both engines' designs and how both engines work. Before we see the detailed design, let's check what is important for in-memory table design. So first is memory management. This is how the engine allocates memory from operating system and how they release them. And the second is the data storage. That is how to storage raw in memory, the raw data in memory. And the third one is index, which is how to implement index. For most in-memory table, the index is either hash index or retrieve index. The last two is log management and transactional management. They are important for table design, but for internal temporary table, they are not very important because internal temporary table are only created by optimizer or executor. We cannot control them. They are created after the query begins and just closed before the query ends. So log management and transactional management is not that important. So in this slide, we just talk about the above three aspects. First of all, let's check heap engine's memory control. The heap engine's memory management is a tree structure. Every node in this tree is a memory block which is roughly 64 kilobytes. The bottom layer, or we can say the leaves of the tree, only stores data, just like a B+ tree. And the internal layer only stores pointers. The pointers are pointing to the block in the next layer. If we need to allocate a new block, we just need to allocate a new memory, a new block of memory, and put it under an empty pointer slot, just like this. But if the tree is full, which means there's no empty pointer slot, we cannot put it into an empty pointer slot. We just need to create a new root block and make the old root block its child. This operation will make the tree grow a layer higher. And since there are at most 128 pointer slots for each internal block, there will be at most 128 to the power of 5 blocks, because the maximum height of the tree is 5. Is 5, and at most 2 to the power of 21 gigabytes RAM memory can be managed totally. And besides, both data and hash index are based on this structure. And for data storage, raw data in heap engine are stored as fixed row format, and there will be an extra pointer next to it. So the atom will a little larger than the fixed row format. I didn't try that myself, but according to the official website, heap engine in MariaDB and MySQL that does not support the blob and text data types either. And since the row format is fixed size, the number of records per block is fixed. So if we regard the bottom layer as an array, the record in this array is arranged one by one. But there are some records that are deleted. Besides, the pointer are also arranged one by one. The deleted list will be linked as a list with the help of delete pointer. And how to insert a new record? First, the heap engine will check if it's empty in delete list. If deleted list is not empty, we can just reuse the space in delete list. We can reuse the memory. But if there is no deleted record, we will check the last empty record in the bottom layer. If there is still space, we can just insert the raw record into it. But if there is not any space, free space, we can just create a new block and put the raw record into the new block. And how to achieve random scan or random access according to this structure. We can regard the bottom layer of the tree structure as an array. So scan the because all the data are stored in the bottom layer. So if we want to just scan all the data, we can just scan the bottom layer one by one. And in a block, data can be scanned by address because they are arranged one by one. But after one data block is scanned, the next record, the next blob, the position of the next blob needs to be determined based on the position or the number of the first record. Just like if you know the position of the record you want to read, you can find out which child is in with modulo operation. So after several modulo operation, you can find out that the data you want to read is in some block. The whole data structure is essentially a blocked linked list. But the difference is by adding a tree structure index to the block linked list, we can support random access capability. And let's talk about index algorithm for heap engine. There are two kinds of index algorithm for heap engine. The first one is B-tree index. It just reuse the circle code tree.cc and we don't mention it here. And the second one is hash algorithm, hash index. And I think the hash index implemented by heap engine is very beautiful. The most special part of this hash algorithm is that the number of hash slots is always equal to the number of records. Just like, let's explain how it achieves it. Hash mask equals to hash value mode belong. Hash value is the return value of the hash function. And belong is the smallest power of 2 greater than number of slots. Just like if there is 6 records in this heap engine right now, and the belong will be 8 because 8 is the minimal or the smallest power of 2 greater than 6. And how do the records stored in the array in the hash map? Records with hash mask equal to 0 will be stored in slot 0, and records with hash mask equal to 1 will be stored in slot 1. This is just like a common open hash table. But for slot 2, records with hash max equal 2 and equal to 6 will be stored in this slot, because we can only use 6 slots right now because there are only 6 records here. The hash mask equals to 6. The slot 6 is not ready yet, so we can only store it in slot 2, which is 6 minus 4. 4 is half of belong. And also the records with hash mask equal to 6 will be stored in slot 2, just like the last one. And same as others, 4 and 5 will be stored in slot 4 and 5. And how to maintain the structure after the insertion. Let's see, after insert one record, just like this, the number of records will be 7, and the belong does not change, it's still 8. Now we scan all the records in slot 2 and pick up all the records with hash mask equal to 6 and put them into slot 6. And now the structure is maintained. We can use it. We can insert the new record now. And the implementation of the hash table of heap is very complicated. And in principle, the hash table is an open hash table. But in actual storage, all hash entries of the heap table are stored in slots, which does not waste any memory. Which means there's no memory waste in this algorithm. And also the underlying this structure is also a block linked list, just like the tree structure. Let's see timetable, memory control. The memory management of timetable engine is more wild. The basic allocation unit is block. Timetable allocate block from operating system, not just RAM memory, but also mapped files, which makes the timetable can use less memory and can use mapped files to make the memory unlimited or make more memory, use more memory. And it does not allocate the same size block each time. For example, first time it will allocate 1 megabytes memory block, but if it's not enough, it will allocate 2 megabytes and 4 megabytes, and the next time 8 megabytes. And at last, it will allocate at most 512 megabytes at most. And the blocks are used everywhere of timetable, not only data storage, but also STL containers and some temporary memory. And if we delete the chunk from, if we release the chunk, it will be marked as deleted in the block. If the deleted block chunk is the last block is the last chunk in the block, we can reuse it. But if it's in the middle, timetable will never reuse it. And timetable implement an STL library, STL style like STL style allocator. And each time the server create an timetable, it will borrow an empty block or a pre-allocated block from a global log-free block pool. And once the timetable is closed, it will return the block back to the block pool, which reduces the one memory allocation. And if the pre-allocated block is not enough, is not large enough, timetable will allocate new memory from operating system, and once all chunk in block are released, the block will be reduced, will be released, will be freed and released to operating system. And this may cause some issue if there are some scenarios like a loop, every round, for each round, it will allocate a temporary memory and free it. And in this case, it may cause allocation jitter, that the timetable will allocate a new block because all the other blocks are full, and once it's used, it will be released, and for the next round it allocate again and released again. This will cause very serious allocation jitter. And this is the bug mentioned at the beginning of the slides. And let's see how to store data and index in timetable. For data, for data, timetable is also stored as pages. It's like a linked buffer. It's like a block linked list. Each block, or we can say each page, is for 64 kilobytes, and it has a head and tail. Every record, if the record contains varchar, blob, text, or other dynamic format, dynamic field, it will the block linked list will only store the metadata, and the real data will be stored in other place with pointer. And if it doesn't contain any dynamic field types, it will use a fixed row format. But we know the upper layer, the circle layer, only use fixed row format. So if the row contains some dynamic field, timetable has to combine and format the raw data and before send it back to upper layer. So it may cost some time, but this will store separate store metadata and raw data separately will save some memory. If you want to scan all the data, just scan from header to tail, and you can use the pointer directly. It's just a block linked list, like heap engine, but the difference is it does not support random access, because it's just a normal block linked list. You can't randomly read some record in one page, in one inner page. And the difference between and index in timetable also support hash index and B-tree index, which is not B-tree index. I make a mistake here. It's red black tree index, and but it does not implement by itself. For hash index, it uses strlib unordered map, and for tree index, this is arbitrary index. It uses stl container std map, which is much more easier and simpler. And after analyze the design of heap engine and timetable engine, we can compare these two engines from low level. The first is why timetable is faster in this scenarios. First is its allocation is fewer for million test scenario. Timetable only need to allocate 30 times, but heap engine need to allocate more than 1,000 times. And timetable use simpler data structure and algorithm, which makes the execution more faster. And timetable do less calculation and memory access. It use pointer rather than position. And for hash index, timetable use ordered map, but heap engine implement by itself. But hash tables of heap engines are always 100% full, so it will suffer from collisions. And the second comparison is why heap use less memory. Because heap has finer grained memory allocation. Heap engine only allocate 64 kilobytes once, but timetable will allocate more than 500 megabytes at most. And heap engine will always recycle the deleted rows, but timetable for most deleted rows, timetable can't reuse their memory. And the third is heap engine use memory efficient hash tables. Although it suffers from hard collisions, but it sure saves lots of memory. But it's not very fair to compare the two, compare heap engine and timetable engine. For timetable engine, it's just an internal temporary table. You can't create a timetable by yourself. Only optimizer or executor can decide whether to create a timetable table. But for heap engine, it's not just an internal temporary table, it's also a memory table. Users can create a heap table by themselves. And if heap engines use too much memory, when we use heap as a memory table, it will last for a long time in memory. So it will make some effects on other executions. That's not what we want to see. And there are some ideas that how to make engine better. For heap engine, we can separate the separate the data structure for data storage and indexes storage, because their logic are different. Some compromises are made to support both data and the index at one kind of data structure. If we can use separate data structure, it may be more efficient. And for timetable engine, we can separate data and index memory management and do some recycling work in timetable. Because for now, we are using the same allocator for both data and index, but we know the data allocation. For data allocation, every time we allocate 46 kilobytes, but it's more careful for index or STL or container or temporary allocation. So if we can separate them, we can optimize the data memory management by management. But even with this optimization, the performance and memory efficiency of the two are still different. This is because the difference, the underlying principles of the two storage engine are different. The heap engine, for the heap engine, it just want to use as less as possible memory during execution. But for timetable, it's just more careful. You can use timetable want to use less memory, but if it's hard to use less, it just allocate a new block. It's not as much less as possible. So as less as possible. So it will use more memory, but it will execute more faster. So it's hard to say which is better, which internal temporary engine is better, because they are different. So just like 21 for the rules, just use the right engine in the right scenario to achieve better performance. Thank you. And by the way, I'm working on character sight and collisions right now. If there is some other chance, I'd like to show you the share with you the learning journey on that area. Thank you. Thank you.
My name is Alexander Barkov. I'm a software developer at MariaDB, and today I'd like to tell about a few tasks improving consistency, performance, compatibility, and ease of use in MariaDB server that I had a chance to participate in recently. This is the plan for this session. First, let's discuss a couple of optimized tasks, then tasks improving Unicode support, and then a few tasks improving stored procedures and compatibility. The first optimized task improved performance in cases when we compare a timestamp column to a datetime constant expression. Historically, datetime is compared to timestamp as data because datetime has a wider range than timestamp. Then two different timestamp values can have the same datetime very near the daylight saving time change and near leap seconds. And also now there are daytime gap values during the spring forward TST change. And MariaDB adjusts these values inside TST gaps to the start of the gap. Comparing as date times takes all these irregularities into account, but it is quite slow. The timestamp side gets converted to datetime per row, and this involves a slow local time system call. So this task implements the idea which is when the datetime site is a constant and the datetime site is inside a reliable wide monotone continuous period, then those arguments can be compared as timestamps. So we can compare the datetime argument once to timestamp and before statement prepare stage. And then during the raw processing, no data conversion is needed anymore. Benchmarking on 1 million rows showed quite a good performance improvement. The next thing in Optimizer adds new notifications if an index cannot be used by the range optimizer because of data type mismatch or collation mismatch for text data types, for text string data types. And notifications can be shown either in the show warnings statement output or in slow load. These notifications are off by default for backward compatibility. So to enable them, one can type as a DBA the following script, and then run a new user session. And so now, if a statement uses comparison predicate in the where clause or a like predicate or in and between predicate, and the index cannot be used, a new message gets added to the diagnostics area, so you can type show warnings to see what was wrong. So in this example, the message says that the KA wasn't used because because the column A is of type archive, but the comparison is done as a number, and indexes cannot be used in this case. Also, these notifications work in case of joins as well. And now, if you take a look into slow log, we can see the usual output is a new part bringing exactly the same nodes that we saw in the show warnings output on the previous side. So this new feature makes debugging your keys much easier. The next group of tasks improve performance and Unibot compliance in MariaDB server. In 10.10.1, we added a number of new Unicode collation algorithm collations based on Unicode version 14.0.0. But we didn't just add new weights. This task made much more. So first of all, these new collations can be used without the character set name prefix, and the character set prefix is detected automatically from the context. This is a step towards the SQL standard, which says that a collation can be applicable to multiple character sets. To list new collations, one can type this show collation statement. As you can see, there are no prefixes, there are no character set prefixes in collation names. And there are accent-insensitive and case-insensitive and part-non-part combinations. One language-neutral collation, UCA 14.0.0 was added, and also all language-specific collations which were supported in the previous implementation of UCA collations were added as well. And so here on the output, you can also see that the character set and the ID and the default columns are not. That actually means that this is a collection can be applicable to multiple character sets. The list of new collations can also be extracted from the table collation character set applicability in the information schema database. So here we can see old columns collation name and character set name, which were in this table before the change. There are also 3 new columns: full collation name, which displays collation names, including the character set name prefix, and there are 2 other columns, ID and is default. The fact that we don't have to type collation prefixes for these collations makes it easier to use them. So here in this example, I create 2 columns with different character sets, and I type collation names without the character set name prefix, and show create table displays that the same name, UCA 14.0.0 ASCI was translated into 2 different collations automatically using the character set context. Another task which was implemented immediately after the UCA 14.0.0 collations was updating case folding data from the latest Unicode files. So if you compare case folding.txt between Unicode 5.2.0 and Unicode 10.0.0, we can see that about 400 something new entries were added. And of course, our old collations didn't support all of them because we didn't update this data since those collations were added for backward compatibility purposes. So the new collations, the Unicode 14-based collations, of course, take all those new case folding pairs into account. And this slide demonstrates that. The next task improved performance of the UC collation algorithm. So the intent was to improve performance of the ASCII range and on the 2-byte character range. So a switch from UTF-8 general CI to new collations does not degrade performance of the server. So this does demonstrate that new collations are not really bad. And this task also, this page also compares performance of MySQL 0900 AICI collation to MariaDB UCA 1400 AICI collation. And as you can see, MariaDB is much faster on the 1 and 2-byte character range, which is really important. But it's a little bit slower on the 3 and 4-byte ranges, which should be tolerable. Now the Unicode-related tasks. It's a new simple variable to choose a default collation for a character set. And so if you take pre-NF 30164 server and type this create statement, then the character set UTF-8 and before clause was always actually translated into character set UTF-8 and before collate UTF-8 and before general CI, because this collation is the hard-coded default for UTF-8 before. And the only way to choose a non-default collation was to type the collect clause explicitly, which of course was not very convenient for example, German users or other users using language-specific collations. The new variable makes it much easier, so no annoying collect clauses are needed anymore. You can set a new variable character set collations to list of comma-separated set equals collation pairs. For example, like this, like on this slide. And after that, this soft default will be used instead of the hard-coded default. So if I set character set collations to UTF-8 before equals say 14 German 2 AICI, comma Latin 1 equals Latin 1 German 2 CI, which would a typical German user do. And then if I create a table without specifying the complete clause in columns after the character set clauses, then the character set clause is translated, is extended, and taking into account the new variable value. And of course, this variable can be added to my CNF path, so you don't have to type this character set collations in every session. Unicode-related tasks makes MariaDB server print the collate clause even if the collation is the default collation for the character set. Previously, to save space, the collate clause was not displayed in such cases. Now, to address this change with character set collations variable, the collate clause is displayed always, even if the collation is equal to this current sub-default of the current set, or even if it's equal to the hard default. This is needed for backward compatibility, and this task was implemented in all releases starting from 10.3, even before this new variable character set collections was added. The next set of tasks were done to improve routines, stored routines, and compatibility. The first task, raw variables do not get assigned from success, fixes the problem that the set statement with a raw variable on the left side and the subselect on the right side didn't actually work. So the syntax was accepted, but nothing happened. The raw variables, the members of the raw variable didn't change. They kept the null value. And after this change, everything works consistently. So no matter what you use, set into or set raw variable equals subselect, everything works correctly. The next task is the raw data type as a stored function return value. So a stored function can now return either explicitly typed row when you list all its members and together with their data types. But also you can type to use the structure of this row from a table. For example, row type of T1 says that the structure of this row should be loaded from the table T1. And also on the terms of this task, the type of T1.call1 makes it possible to use the data type of a scalar return value from a table column. And also in the Oracle compatibility row, similar core data types were implemented. T1% row type tells to get the structure of this row from the table T1, and T1.call1 and %type tells that the data type of the function should be taken from the table column. So this example demonstrates this new feature, and it really brings the ease of use of stored procedures, of the ease of use of writing, the ease of writing stored procedures to a new level. So take a look into this create function statement. So what it said, the function, the data type returned from this function should be taken from the table T1, and the subquery can be even typed as a return value. This is the anonymous block demonstrating to use this function return row. it makes writing stored procedures and function really easy. Instead of adding parameters to functions whenever you add new columns to table, or instead of changing the data types of the function parameters every time when you change the structure of your table, you can just type that the function returns the row of the table type. Another highly requested task was that the Oracle compatibility mode didn't support csref cursor. Now this task makes it possible. So here I create a table, and then I create a function, and the return type of this function is csref cursor. So then I, inside the function, declare variable of csref cursor data type and open this cursor for the given select statement, and then I return the opened cursor as the function result. And inside the procedure, the stored procedure keyboard, I use this function to initialize a cursor variable and assign the function value to this variable. And then you can find the regular loop fetching data from this cursor. It looks exactly like it would look in case of stable cursors of stuff.
Anita, online.
Did it complete?
No, it doesn't seem so.
That was
Oh.
abrupt and
It's a projector, it's not my equipment. Oh.
You ready for questions?
hang in there. Hang in.
Can he hear us? Yeah, probably if I put that on.
Can you hear us?
And because try to connect.
Yes, we can use a signaling system that was
Ку-ку,
used
скажи
previously
что-нибудь.
in Mary.
Hello, hello.
Hello, hello. Okay, we can hear you.
Hear me?
Yes.
It looks like our
Yeah.
role.
Okay.
Yeah.
Hello, guys. Thanks for listening, and I joined to answer your questions if you have any.
So you were saying?
Okay, so if you have no questions, then I can share some thoughts about what I heard earlier today. For example, in Federico's presentation about stored procedures, he mentioned the array data type. I think that implementing the array data type as a stored procedure data type is a very simple task actually. It's like maybe a couple of days to work. And implementing it as a table data type, as a table column data type, is harder. But for stored procedures, it's really something simple.
He wasn't interested in that particular use case as much, so just as an argument.
I think it's an important feature to have the array, the variadic sized, variadic dimensional arrays, because they are widely used for storing data that doesn't fit into text. Actually, to store a number of counters that can be leveraged by the application itself. Like you store it in the form of the array, or basically it's a tensor, because you have multiple dimensions. So the software can pack the data into these variable sized array, variable dimensions array, and put it there.
And also one more thing. What you mentioned today, that we improve the performance of the for loop, and this may sound like it was already done and pushed. No, it's only in a prototype. It's not even in a stage branch yet. It's just a patch, and we'll go forward further on it. But the results of experiments are very promising. Performance really improves about like 2 times at least.
Yeah.
So,
I do have a question. What do you think about implementing the vectorized version of some functions and expressions?
for example,
Simple math. Simple math is the natural way, is the natural client for this, natural use case for CMD. The question is how to supply the vector inside functions and function and expression.
So now all functions get just single value and calculate the result. So we need to refactor the whole data flow process. So we need to collect data into some buffer, to collect, say, a few hundred or 1,000 values, and then run a vectorized function on top of this array. That's quite a lot of work, I think.
There is a feature that I mentioned today, function multiversioning, that allow one to define what would be the variant of the function code for a certain architecture that is detected in runtime. So the only downside of this function multiversioning is that optimizer, the CPU optimizer cannot not CPU optimizer, but compiler optimizer cannot use these high funcs, use it underneath to optimize to inline code, because the actual function pointer will be supplied in the very beginning of a runtime. So there might be some limitations, but nevertheless, there can be a wrapper that collects the values into a vector and supplies it into a vectorized addition function, given that we run on a platform that at least supports SSE 4.2.
Well, I haven't thought about this idea much so far. But yes, function can have an SQL function an implementation of an SQL function inside the server can have two APIs for the single value and for the massive.
No, I'm talking about item methods.
Yes, yes.
Okay.
And how to prepare data properly for this massive.
As I said, we can have the same scalar API, but underneath, if we are on a platform that is SSE 4.2 capable, you can collect, accumulate the values into the vector and fire it when it is ready. But the API will be the same, but with function multiversioning, there will be a runtime dispatch that tells, now we are able of vectors, we're capable of doing vectors, so we can take this one that accumulates and run it vectorized.
Yeah, sounds doable, and I guess we need to start with writing a Jira ticket for it.
Yeah, makes sense.
But does, like, is aggregation operations actually a bottleneck? Like addition? Do you mean you will you will save time on doing like additions or calculating maximums this way, right?
Yeah.
But if you calculate, I'm afraid that if you currently take a query which computes a sum over like a really large table, the addition operation will rarely be the bottleneck. Like it will just walk up and down the stack by fetching a row from an engine. Then it will pass it over to aggregation function. So if you just vectorize one CPU operation add, that's wouldn't be as the advantage wouldn't be that big.
The thing that I face with in column store, that is for sure, but at least it will point to bottlenecks, first thing. The second thing, I was thinking about adding two column values, not the aggregation, but aggregation also fits naturally, and it's also a natural use case. But from the other perspective, you would pave the way for those who want to invest their time sim-defined vectorizing.
Yeah.
You just make a framework or some examples, because it's always easier to follow somebody comparing to be somebody who is the first person in that area.
Well, yes, but so basically confirming what I'm saying, that doing this particular thing won't give you much. May open some opportunities for somebody else, but this particular change would not make a big difference.
Yeah, that's not a killer feature for sure.
Can I have a question on collations? It's
Yes,
Daniel.
sure.
I was meant to ask it before, but there's an alter table convert to character set collation SQL statement. Now that the UCA 1400 collations, 1900, don't actually matter what character set, could we have an alter table collation statement?
Yeah, I see. So, if I understood the question, you would like to have a statement which changes the collation without specifying the character set, yes?
Correct.
I see. Yeah, there is no thing like this yet, but it should be doable, and I think it's maybe like a couple of hours of work.
I suspected so.
But will storage engine rebuild the table, or will it? Is the DB smart enough to understand that if it's not an indexed column, that we don't need to rebuild the table if we change the collation?
It's not currently.
Yeah, it will rebuild the table because the idea is just to skip the character set clause.
Yeah,
to simplify the syntax. But under the hood, it will do still the same thing that happened for.
There are plenty of optimizations still to be had in alter table.
Yeah,
yes.
Then, continuing on the character sets, like, do character sets actually matter? Like, this is probably a question from the uninformed. Can I just use UTF-8 and B4 for everything now, or there are some use cases where I want to use something else still.
Yes, you can use, of course, UTF-8 before for everything, but national character sets, like for Greek, Cyrillic, Arabic, they use 1 byte per letter. And in UTF-8, those letters will take 2 bytes. And of course, this is not a good idea to increase the size of your database just 2 times if you want to store only, say, Cyrillic or only Greek.
Oh, okay. But you need to have.
So, for example, if you have a table with national error messages, like with translation, and 1 column is for Arabic, 1 column is for German, 1 column is for Russian, 1 column is for Greek. It's a good idea to have those messages in national character set because they will use much less space.
Okay. But you need to have quite a lot of errors or quite a lot of error messages for it to have any sort of impact.
Yeah. Well, not necessarily error messages, but just any translation.
Like how much is written in Greek in the entire world? Like, can you store that on your laptop? No offense to anything Greek.
Well, Chinese would be one example. In MySQL 5.7 they have this GB 18030 standard, which uses 2 bytes per Chinese character. And if you use Unicode, you need 3 bytes. So that would be more efficient, but we don't have that in MariaDB.
Yeah, we've been trying to ascertain how popular that is or not, and I haven't got a clear answer yet.
Well, I think it's important for some Chinese because they wanted to have it in MySQL 5.7.
Fair enough.
Yes, we have a Jira ticket for this to support the GB 18030 character set, but we haven't had time yet to implement.
Understandable.
Continuing, and then let's touch the first feature. Like if I specify all these new if I use all these new collations and because of that the optimizer cannot use an index to make lookups, do I get a warning?
Yes.
It will work.
Yeah.
Oh, okay, that's good.
For new collections, it will work exactly in the same way like for old collections.
But I will get a warning if I get like a collation mismatch if I'm like.
You will get one.
Oh, okay. Because now with new collations there is much more opportunity to make like an error. Okay. Okay, thanks.
But it's only 1 error message out of the many you possibly could have. Thank you, Bob.
Thank you.
Much appreciate you coming in.
Thanks for listening and for your questions.
Thank you, Bob.
Bye.
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 Walensky, and I'm going to be talking today about improving the security and usability of TLS in MariaDB. I've been in Amazon Web Services open source core team working on MySQL and MariaDB databases for about 2 years. I've also contributed to a lot of open source software, including most relevantly here, the OpenConnect VPN client, which uses TLS and related protocols to secure connections to a whole lot of different kinds of VPNs. Quick outline, I'm going to give some background and motivation for what TLS is, why do we need it in applications like MariaDB. Then I'm going to give a critical look at TLS in MariaDB. I'm going to propose some solutions, and we should have some time at the end for live questions. So first, the background. What is TLS? Why do we need it? How have those needs changed over time? TLS stands for Transport Layer Security. It's designed to provide privacy and security to other network protocols. Early versions of it were called Secure Sockets Layer, SSL. That name, SSL, has proved to be very sticky, even though it's 25 years out of date, and it's still used, including in MySQL and MariaDB. And the TLS protocols have been revised over time to improve security, and the goal here has been not just to fix known vulnerabilities, but also to think about newer and more sophisticated threat models against TLS. So TLS promises applications and their developers and users that if it's used correctly, it will provide end-to-end encryption and authentication. Applications can create a confidential channel over an untrusted network, and it provides peer authentication. Clients can use TLS to cryptographically verify that they've established that channel with the intended server. And for the folks writing the code, TLS aims to be a drop-in replacement for unencrypted network connections like TCP and their programming interfaces. So a lot of applications, including MySQL, started adding support for TLS at the beginning of the century. And it's worth thinking about what were the privacy and security concerns and what were the threat models that users were worried about. And I don't want to oversimplify this too much, but the big concern is that everything on the internet was in plain text. If you could capture my packets, you could read them. So if we think about a computer library such as I might have been in 2005, one kind of threat would have been an opportunistic eavesdropper. Let's say this woman here is running Firesheep, a browser extension that could be used to steal Facebook and webmail logins by sniffing the wireless network traffic. Or we might have to deal with some kind of very simple sensor, like a router that looks for BitTorrent packets or HTTP requests that are trying to download executable files, decides that those are threats, and injects TCP resets to kill those connections. Very frustrating if you have a legitimate use for those. Since then, we've had ever-increasing computing power. More and more of everything is online. More people studying internet protocols, better organized and better funded attackers, and more sophisticated threats to privacy and security on the internet. And approaches that were good enough back in 2005 no longer are, and applications and protocols need to keep up with this. So one thing that I think we've all observed over the past 20 years is a consolidation of the control over the networks that we use. 20 years ago, MySQL server might have been running on a small LAN operated by a university or on the premises of a small company. Now we're mostly using large wireless networks and running applications inside data centers that may be outside of our direct control. We also had a lot of revelations about the extent and expense that governments are putting into internet surveillance, starting with Snowden's disclosures in 2013 and continuing since then. So as a result of these kinds of changes, we need to think about pervasive attackers who can observe basically all of our network traffic, including intelligence or censorship agencies, internet service providers, data centers, and collaborations among those groups. So what do we think these pervasive attackers can do? We think they can track any of our network connections statefully, meaning they can see my attempt to connect to a particular server, maintain information about that connection, and follow it over time. They can inspect and log and inject packets at any unencrypted layer. They can fingerprint for vulnerable software versions, and they can research and discover vulnerabilities on their own and exploit them without public disclosure. They can also inject attacks that are targeted against specific individuals or groups. So this gives us a lot to worry about, but I wouldn't say it's a need for despair. There's been a very consistent expert consensus over the last 10 years that whatever the capabilities of the most sophisticated intelligence agencies in the world may be, TLS implemented and used correctly is a very strong defense against these kinds of pervasive attackers. We do know that they exploit vulnerabilities, so that means we need to use well-funded, well-tested, and standards-compliant technologies like up-to-date TLS libraries. Also, these pervasive attackers can do a machine-in-the-middle attack. And so clients must verify servers' identities. That kind of attack is very fundamental to some of the vulnerabilities I'm going to describe here, so I want to talk about it in detail. Basically, I might have an application running on my phone that wants to connect to some remote MariaDB server. So I try to create a TCP connection to it and then start a TLS handshake. But the machine in the middle, rather than allowing that TLS handshake to go through, it splits it and completes two TLS handshakes, one with me, the client, and one with the server. If we don't detect this condition and abort the connection, then I, the client, will think I have an end-to-end encrypted channel with the server, but it's actually with the MIDM, and the server thinks it has a channel with me, but it's actually with the MIDM. An attacker who's done this successfully can read, relay, and modify traffic just as if it were unencrypted. So in order to defeat this, clients need to have a mechanism to verify server identities. Unfortunately, TLS and related infrastructure give us tools to do this. So what do users expect from TLS? I would say that TLS or SSL is a brand. And if I look on the websites of major companies to see how they advertise their product security, they often reference TLS or SSL. So here's just a smattering, including MariaDB, Amazon, Skype, F5, and Credit Card Issuers Consortium. If an application says TLS or SSL is in use, users expect the data transmitted to be without the possibility of eavesdropping, forgery, or interference. And if those expectations are violated, then saying that TLS is supported and enabled is at best incomplete, and at worst quite dangerous and misleading for the users. So users really expect to be protected against these modern threat models. Many users know that they want TLS, but not how to use it well. So applications should make it as easy as possible to use TLS securely by default. That means good design, secured by default configuration, fail-safe, secure behavior, simple configuration, good documentation, including communication about changes that affect security. Also, if a feature makes it too easy to use the software insecurely and there's a better replacement for it, remove it. So now I want to take a look at how TLS is used in MariaDB. And I'm going to start by describing an overarching technical problem that I see and the resulting vulnerabilities, and then move in the direction of some user experience problems. So first, if an application or protocol wants to be able to switch to TLS, that needs careful design. Like many applications, MariaDB starts out with a plain TCP socket and then switches to using TLS over the same TCP socket. It's called opportunistic TLS or start TLS. This needs to be designed so that it is backwards compatible with peers who can't do TLS if necessary. And it also needs to ensure that TLS-capable peers are protected against downgrade attacks that might prevent them from using TLS or degrade the security of their TLS connection. And it should leak as little information as possible. One way that this can be done is by throwing out any data or configuration that's exchanged before switching to TLS. If the state of an application is influenced by the state before the handshake, then that results in information leakage and the possibility of downgrading or forgery. So if you want to implement a mechanism for switching to TLS correctly, you should start with designing the protocol for doing that, not the other way around. Think about if it'll meet the requirements in terms of security and backwards compatibility. Then you should use language features and good program design to ensure that pre-TLS and post-TLS state are isolated. Make sure that your code doesn't use global variables, no long-lasting stateful God object that exists before the TLS connection and after, and make the code as compact and self-contained as possible. And so here I've given the sketch of some C code that could do this, and it highlights these features like doing a TLS handshake immediately, using a TLS library to do it as soon as it knows the client wants that, throwing out the information that was exchanged before the TLS handshake, and then not creating a stateful application state object until after that handshake is complete, and then isolating that in its own function, keep it as short as possible, and isolating it from the surrounding code. I had a bunch of slides here trying to highlight problems in the MariaDB server and client code for switching to TLS. I think the level of detail wasn't right, and they were too long as well, so I'm just gonna give you some of my thoughts after studying this code. I think that the protocol for switching to TLS has a flawed design. It seems to have been added as an afterthought without thinking about some of these issues. There's a lot of global state and spaghetti code, if, then, else, hard to follow, hard to read, test, or simplify, and that applies to both the server and client implementations. There's no separation of concerns between the code that's responsible for setting up TLS and setting up the application connection parameters and authentication. There's very little separation of application state before the TLS handshake and after the TLS handshake. There's also a very large amount of code involved. Most of it lives in a file called SQL ACL-CC, which is 15,000 lines long and includes code for multiple authentication methods in addition to TLS setup and general application and connection setup. So a number of vulnerabilities result from this. And using these vulnerabilities, pervasive attackers who can intercept MariaDB connections can undetectably downgrade these connections to plain text or undetectably MIDM the TLS with the two TLS handshakes like I showed earlier. They can mislead clients and denial of service attack them by sending forged errors with no TLS awareness needed whatsoever. They can fingerprint clients for location-specific information like character sets, and they can fingerprint clients for specific software versions and launch other attacks based on those. The first two of these can be defended by verifying server certificates in the client, but unfortunately, that is not on by default, and it's surprisingly hard to configure, so a lot of users just don't. So here's a vulnerability I reported in early June, which is that clients improperly trust errors sent before the TLS handshake. Basically, client software that's using TLS should not trust messages that are allegedly sent by the server before the TLS handshake is complete, but MariaDB connector C clients do. The code where this vulnerability exists is a function called myRealConnect in the client library, and it has a couple hundred lines of fairly complex code before this problem appears. It's quite hard to read the code and figure out whether or not the client has switched to TLS yet at this point, and I think that's one reason for the vulnerability's existence. So what can be done with this? A client tries to connect to a server with TLS. A MIDM attacker injects a fake error packet. Looks like this on the wire, plain text, not encrypted. This error packet contains a specific error code that the attacker controls and a specific message that the attacker controls. And the connector C library will report these errors as a real error coming from the real server with no indication that they were sent before the TLS handshake. It's true that clients need the ability to report certain errors before TLS handshake is complete for things like failure to do DNS lookup or failure to verify server certificate, but those error conditions are determined by the client and they should not involve trusting information sent by the server before the handshake. I was asked when I reported this if I think it's a problem, and I would say, in terms of immediate risks, I don't know of a way that this vulnerability can be used to extract or manipulate data in a MariaDB database, so that's good. But it's trivial to use it for denial of service attacks. You can inject wrong password errors to convince clients to stop retrying, or inject temporary failure messages to get them to keep retrying, or inject things like out of resources errors to get clients to stop trying this server and try and connect to another one, perhaps. There's a lot of potential for mischief here. Then in terms of future risks, I discovered this because I was trying to add a mechanism in the protocol for servers to send error messages to clients telling them to redirect to another server. But as long as this bug or something like it exists, the MariaDB protocol can't evolve in that way. We definitely don't want the clients taking consequential actions like connecting to another server based on error messages if those error messages can so easily be forged. So this imposes some limitations on ways that the protocol can evolve. I created a fix for this issue in Connector C. It's very small. It's been up since June 12th, and I revised it based on some feedback from Sergey Golubchik and Andrew Hutchings. Next, later in June, I reported a couple JIRAs, which I paired together as vulnerabilities that result from badly designed protocol for switching to TLS. Basically, clients send too much information before the TLS handshake, and the servers require them to do it. And this results from the poor design of the protocol for switching to TLS in MySQL and MariaDB. Basically, the expectation that near identical information-rich greeting packet gets sent once in plain text and once over TLS. And in this pre-TLS greeting packet, clients reveal their capabilities, which indicates certain options that the user has configured, but also information about the version of the client software and what version of the protocol it supports. And then the clients also reveal their preferred character set and collation in plain text. So the risks of this is that it gives a lot of opportunities for fingerprinting the clients. It'd be pretty easy to iterate through every release of Connector C, build it, and see how its default capability bits change. And pervasive attackers might use that to identify specific client software version and target those clients based on other vulnerabilities they may know about that I do not know about. Also, this gives the possibility of geographic fingerprinting based on character sets. If your client says it's using the KOI8R character set, which was formerly widely used in Russia, and it's traveling over an American network, it will stick out like a sore thumb, vice versa. So as I said, this is a protocol flaw. It can't be fixed in a fully backwards compatible way in either the client or server alone. It requires an evolution in the protocol. I have a couple PRs up that do this. Submitted in early July. I initially got quite a bit of feedback. They're still open. Basically, the current status of these PRs is that they enable the client and server to do a new form of TLS handshake, MariaDB handshake v2, and other compatible client libraries are interested in supporting this. And if the server says it can handle the v2 handshake and the client can too, then the client will send a greeting packet that contains much less information. All that that packet will say is, yes, I can do TLS. When I reported the previous issues, it became clear that it would take a while to figure out how to deal with them and to resolve them, so I started thinking about smaller pieces of them that I could bite off that would be easier and quicker to solve. I found one immediately that I would consider a pretty severe vulnerability, but also quite easy to fix. It turns out that Connector C clients reveal in plain text whether or not they are verifying the server certificate. This is a protocol level problem, a subset of the previous ones. One thing that contributed to it is that protocol analyzers like Wireshark formally showed this particular bit as unused, but it should actually be labeled as, does the client verify the server certificate? And I fixed this with a PR for Wireshark. In the real world, many deployed MariaDB clients aren't actually verifying server certificates, even if they're using TLS for encryption. And those clients are literally revealing whether or not they can detect the basic TLS MIDM attack. I think the risks of this are potentially enormous. If pervasive attackers already know about this vulnerability, then they are already using it to opportunistically decrypt tons of connections from MariaDB clients without anybody noticing it. So it's a subset of the previous more complex vulnerabilities, but it can be fixed with a purely client-side change. I've had a PR for this up since early July. Could be done in one line, but I added a bunch of explanatory comments here. There's another issue that was reported in 2020, not by me, and that is that Connector C clients, which have been told to use TLS, will silently switch to a plain text connection if the server says it doesn't support TLS. And this is just an absolutely trivial downgrade attack that requires no knowledge or understanding of TLS whatsoever. It exists in this form since at least 2015. And I submitted a few line fix for this in mid-June. This is in some ways a technical problem, but in some ways a user experience problem. Neither the MariaDB-help documentation nor the online docs mentioned that this option might result in an insecure plain text connection. And I would say, going back to what users expect of TLS, it's just a massive violation of user expectations for an option called --SSL to result in a plain text connection. Users who specify that option definitely don't want a plain text connection. The JIRA submitter made this case quite clearly 3 years ago, I think. I don't think this behavior is expected by users, and the industry standard is for designs to fail safe, not to silently downgrade. I've been making a fuss about this one recently as well. Moving on to other user experience problems, the defaults of MariaDB are too insecure. MariaDB servers accept non-TLS clients by default. MariaDB Connector C accepts non-TLS servers by default, and it doesn't even try to use TLS if the server advertises it. MariaDB Connector Python is very similar, just a thin wrapper on Connector C. It's true that the MariaDB reference command line interface started defaulting to --SSL in 2022, but still there's still no server certificate validation by default. And the previous vulnerability I described makes that option, --SSL, even more ineffectual than might otherwise be thought. I'm going to skip over this because I already talked about it. But basically, if you actually want protection against the modern threat model in MariaDB, you need to use the command line option --SSL verify server cert. The docs are a little cryptic, but they say TLS is also enabled even without setting the SSL option with certain other options. And I wonder if the folks following this presentation, who are probably know more about this than anybody else in the world, I wonder if anybody knows off the top of your head what happens if you use MariaDB --SSL at CA to point to a specific root of trust, but without the --SSL options or the SSL verify server cert. If you know exactly what that option does, think about whether individual users will understand it in full as well. So it's very hard to configure certificates to work correctly in MariaDB, to configure server certificates.
Oh no.
Not again.
Yes, it's just shut down.
It's been happening all day.
I saw it, okay.
Does he know that he doesn't
Zoom to do Q&A with us, but we'll do it after we try to finish the presentation first.
If you're already waiting,
Yes.
can you tell something that we are fixing?
Oh. Or he maybe stepped away or something. See if he's there.
We're trying to fix the projector. I don't know whether you hear or see me, but we're trying to fix the projector and then we'll get it back.
Yeah, I was thinking that was going to come up in a minute. I haven't looked at the end of it, no, you did mention he was. Yeah. You mentioned it, I haven't actually looked at it.
No, but you can be in the industry stages of money for reviews, then it was bargaining. I said that was absence of money.
Right. For him, that might not be acceptance.
But you're so right, and like, if I provide you step by step the information how to explore this, you really remove. Do you want me to show? Do you want me to show you the simple instructions? You don't have them. You wouldn't ask me to just walk the door. Yeah, go ahead. If you provide them, then you will look away. But that's right.
Hi there. Super impressive.
You're tired of hearing about certificates, I know.
No. This was really great presentation. And the thing is, here on our screen, nobody sees anything. You were mid-sentence, I believe it was most of it. But we're trying to fix something and then we'll start the Q&A. Oh, yes. Yeah, we're looking in. Just stay tuned.
Very hard to succeed by just experimenting. So let's say we have a typical 3-layer cert chain. I have a server cert. It's signed by an intermediate CA, which is signed by a root CA, which has a self-signed certificate. That's the root of trust that clients are going to use to validate my server certificate. So a user trying to get this set up might try starting the server with just the server certificate specified, or with the SSL-CA option mentioning the intermediate CA, or with that option mentioning the server certificate, or with that option mentioning the root certificate. They might start the client with SSL-CA referring to the server certificate, or referring to the CA certificate, the intermediate CA certificate, or referring to the root CA certificate. All those server options will actually allow the server to start with no errors or warnings related to TLS, but all but one of the 12 combinations that I just showed will result in either of the following client errors: unable to get issuer certificate or unable to get local issuer certificate. And I'm skeptical that users will understand these errors, or that these errors will guide users towards finding the right combination to use here. And I suspect that many users will just give up on configuring certificates and certificate verification correctly, and they will just disable it. So this results from the fact that MariaDB is deferring to the configuration semantics and the error messages of the TLS library, OpenSSL in this case. And I think MariaDB needs better application-specific error checking and error messages. The server needs to advertise a complete certificate chain for this client's verification to work. So it should abort the startup unless it's correctly specified, and ideally give a helpful message, something like, you specified a server certificate and private key, but not a complete certificate chain anchored in a self-signed root. See these options, fix that. And if the client can't verify a server certificate, it should explain where the gaps are in the chain of verification that it's trying to do. Okay, so I want to move on here to talk a bit about solutions. I think there are basically 4 categories here, or 3. First, improving the code. Second, improving the protocol. And third, keeping in mind that backwards compatibility should be less important than actual security and manageable complexity. The vulnerabilities like the ones that I've described here have existed in the code of MariaDB Connector C client and the server for at least a decade, and I expect that there are plenty of others. I didn't set out to find vulnerabilities in MariaDB. I haven't put too much effort into it, but it was quite easy for me to find them while doing related work, or work that just touched on this incidentally. And most of these have taken me far longer to explain and advocate for than it's taken for me to discover them. I would say that the code for setting up TLS and doing TLS handshakes in MariaDB seems to be too complicated to easily maintain, and it's rarely, if ever, been simplified or audited. Improve the protocol. The protocol that MySQL and MariaDB use for switching to TLS is pretty uniquely flawed. I've never seen another one that includes and requires sending so much redundant and meaningful identifying information before and after the TLS handshake. There's no fix for it that will solve the security problems and preserve client-server compatibility across the ecosystem. So it's going to have to be replaced, and I'm not saying to panic and do that immediately, but it's better to do that sooner rather than later before any kind of real-world exploit of the ensuing vulnerabilities is identified. Put in a quick plug. One way that I think you can improve the code and the protocol is by merging some of my PRs, or at least giving me feedback on concretely on how to improve them. In particular, I'll highlight these pair of PRs for reducing information leakage in the handshake. I received a good amount of feedback on this early on. I responded to it and improved the PRs. I think their form is better now, but I haven't had any actionable feedback or input on these in about 2.5 months. Next, backwards compatibility. I think that backwards compatibility is generally a very important thing, and I understand why it matters across the long-lived ecosystem of MySQL and MariaDB and related clients and servers. But backwards compatibility seems to be too often trotted out as an excuse for retaining a lot of insecure by default behavior for too long, and allowing a lot of code to ossify. So when I've reported some of these vulnerabilities, I get responses like, having software that's more secure means nothing if connections can't be made with any and all client versions. Or saying, we can't change the software because from the point of view of the current users, everything is working fine and it appears to be secure. I would say everything is not working fine for users who are using MariaDB --SSL and getting silently downgraded to plain text connections as a result. Some of those users, at least, think they are getting the security that they associate with the TLS and SSL brand, and they expect it, but they're not getting it. I believe that many of them would be far happier for their connections to stop working with a new MariaDB client or server version than they would be if they find out that their usage of MariaDB has been compromised for years due to backwards compatibility concerns. And I think this breakage would be acceptable, especially if the new releases include clear help messages and documentation about what's changed, why it's changed, and how best to adapt to it as a user. I've also observed in the last couple of years that there seems to be a strong tendency in MariaDB towards solving problems by making the software more complex rather than simplifying it. If an existing feature is found to have a problem, the typical response is to add another option or feature, normally a non-default option. So users realize that the --SSL option has no certificate verification, add a new non-default option, SSL verify server cert, to do that. Sometimes more complexity in software is necessary, but I would say it's usually
This is probably a man in the middle attack. Changing his words.
We of course should be far more happy for the connection to stop working instead of.
I think that was an unnecessary evil.
But now it's about 2 minutes of video.
I think that's.
How far are we in the presentation?
2 minutes left.
2 minutes left.
Yeah.
And when we are done, where do I stand for the, like here for him to see me or there for the camera? So I won't see him, but that doesn't matter.
Do you have a pause for in the stream, so we will set everything up? He will be there on the big screen, and you will see everyone.
It's about 2 or 3 minutes to restart this.
So we need the guy who, the guy that jumps around here to be present tomorrow all the time.
Just turn it on by default.
Yeah.
I mean, he was here a few times.
Yeah, but he needs to stay here with that level of flakiness.
I mean, if you want to, but I mean.
Yeah, but really, you'll just, I don't know, profiling users who use code HR. That's.
I mean, it's fully backwards compatible. It's secure by default. It's faster.
Essentially,
Who's using code HR?
everybody uses it.
Yeah, profiling users by their flags. Well.
I mean, if you want an offer, I mean, unless there's a.
The only real thing is error messages and in his example, from examples he has shown, there's no reason for the client to accept authenticate, access denied, or transient error before the authentication. Those errors can't happen there.
Aren't all, I mean, not to say that they're not all, I think a large part of this is extremely relevant. Like
All of that was discussed many times, and his attitude is just break connection for everybody, but after they realize that you are making it more secure, they'll be there.
It's too hard for administrators of databases to think about, and it seems that it's often too hard for the developer community to think about, and that results in some of the vulnerabilities that I've described here. Instead of making things more complex, why not make them simpler? Make the defaults for options better so that users don't have to change them as often. Require secure transport the default in the server. Make --SSL verify server cert the default in the connector library. Frankly, I see no reason that both of these things couldn't be done in the very next major version or even the very next minor versions, all supported minor versions of MariaDB clients and servers, along with clear communication about why it's being done and how it will improve user security. So beyond just making better defaults, you can also remove bad or obsolete options or features entirely. If there's a good replacement for the feature, inconveniencing some users who are using an old, bad, or obsolete option, that's okay. As a simple example of this, I'll reference something that OpenConnect did back in 2016. It used to have a command line flag to disable servers' certificate verification. Many users were using this because it was convenient and because their VPN servers' TLS certificates weren't configured correctly and they couldn't do anything about the server certificate configuration as end users. But this option was also totally insecure against MIDM attacks. So this option has been removed, or at least now when you try and use it, it said this option was insecure and has been removed. You can either fix your server certificate, but we recognize that most end users may not have any control over that. They're not administrators of their VPNs. Or you can use a different command line option to manually verify the server certificate fingerprint. That doesn't scale so well, but it's at least secure against MIDM attacks. So to wrap up, thank you for attending my presentation. I know that in many respects this is a very critical take on MariaDB. I'm highlighting these issues here because I think they're important, and I think MariaDB can be a much better tool and product, more widely trusted, used, and adopted if these issues are addressed. I want to thank many of my colleagues for their support, inspiration, and feedback in preparing this presentation, and hopefully we have a little time for some questions.
Thank you, Daniel Lenski. So that was an impressive presentation. I think well put together, really detailed in many aspects. But I have to say, I am not a security expert, so I know that you have gone through a lot in order to get your pull request to be reviewed. And I think now from the audience we will have some questions and comments by people who know more than I do. However, there's one thing. Except for thanking you for a really well-prepared presentation and detailed putting forth of your arguments, I also want to mention that you are representing our newest sponsor, and not just any sponsor, but our newest diamond sponsor, and that's something that we announced today. So thank you, Daniel, for that sponsorship. Although I don't know your exact role in creating it, but thank you anyway. So I'm now ready for the Q&A and for people to ask questions from Daniel. So Andrew.
Hey Daniel, so what do you make, you got an assessment of Sergey's changes in 11.3? Can you hear me? Hey Andrew. Hey, can you hear me?
So this is a Q session, a question session, not an answer session.
I can. Can you hear me?
Yes. I can hear you, yes.
That's a lag.
Oh, that's a lag. Yeah.
So it's getting through.
So our questions are being relayed via Mars.
Yeah.
I'm sorry about that.
Okay.
I can see myself, but I think this. No, that's not that fast.
Okay. Yeah, it seems like there's a very long lag. It takes about 10 seconds to play it back.
Yeah, we think so too. Ah, there seems to be light now. So, yes.
Okay. So I'm certainly not aware of all of the changes in 11.3.
Okay. Is it that basically there is
there have been a couple specific changes in 11.3, or at least proposed changes that I've commented on Jira, and I'm not sure I should say a whole lot more about them at this point.
Okay.
So I just want to say hi. I'm Sergey Golubchik. We've communicated a lot in emails in Jira and GitHub, so it's just nice to put a face to words. I don't have any questions. I don't have any more to say besides what I've already wrote well in all those media. So.
I have a question. I'm going to ask him also because I'm going to ask him.
Hello, I don't know. I have no idea if you're going to hear this. I'll speak in a very condensed form and ask a question that might be longer or not, so you don't have a chance to reply to me. I don't know how long the lag is, so here goes. I proposed the idea of, if we're going to break the protocol, let's just break it good. And just go with HTTPS behavior and do the TLS handshake immediately. It'll be faster as far as I know. No claims have been done. And if I might be wrong, but if somebody can correct me, that there was a discussion yesterday about a second port or an interface to listen on, so seems like an ideal situation. If you're going to break things, break them good. So just do the TLS handshake like straight away. So what's your opinion on that?
And I'm going to wait for a while.
hear the question?
So hopefully you don't think I'm not responding because the lag is so long. But I would say yes, that is definitely a very viable possibility for simplifying the way that TLS is used. I think that a lot of applications find substantial difficulty in transitioning to using TLS in this way.
Any further questions?
I think, I don't know, I'll be loud. I think the undeniable fact of TLS and non-TLS I think there's an undeniable fact in the trying to do two things on the same port that I believe HTTP or traffic solves.
Yes.
And I can't think of many other server client software that would have similar behavior, just off the top of my head. I know that Postgres has the same problem where although it has a better, it is a client first protocol and they have a special packet for indicating. So Postgres has a better situation and it's not very ideal. And yeah, I guess it's not an ideal solution, I guess.
Yeah,
Unless we just need
so
to
I'm sorry about the lag, and if this is interfering with hearing the answers,
No problem.
but I agree that it would greatly simplify the implementation of TLS and reduce the attack surface in MariaDB to have a separate port for TLS, just like HTTPS does. I don't know exactly why this is, but it seems to me that a lot of products and projects have trouble transitioning to that if they make a dedicated TLS port, it doesn't get very much uptake. It's hard administratively to open ports on servers, and politically, once you have opened a new port, the old port is hard to justify its existence because it's now the purely insecure port. So for whatever reason, a lot of other products, and that would include things like SMTP and IMAP and other protocols, do use this approach of switching to TLS. So I do think there would be a lot of simplification here, and it would be helpful to make a clean break with the protocol. I'm just not 100% sure if you want to go all the way towards switching to a completely separate port. That's probably a product decision, but I agree that technically it would simplify things and reduce the security concerns.
Just addition, I think actually the Postgres protocol, while it is client first protocol, the server responds with yes or no, whether it supports TLS. So I think it literally has the same problem of downgrading, unless there's a client side thing, but there's no exchange of any kind of information. It's essentially just a version, specific value used. So I guess there is the practical approach of going halfway in some sense, then requiring newer clients but using the same port, or you use newer clients and a new port. But I think that in an ideal world, we would have the TLS handshake as the first thing, right? That's kind of my confirming my own beliefs, I guess.
Yes, absolutely. In an ideal world, there's no pre-existing state of the application and no information exchange before the TLS handshake because it happens immediately after the TCP connection. That is the ideal world case. Yeah.
Can I try an SSL connection and realize if it's not an SSL connection?
No, not at the moment. If you would have a client first protocol, then yes, we just start. We could have easily modified to start from TLS, and then it has a very distinct signature. You can see if it's TLS or not. But it's server first. You can do that.
Okay. This was a different presentation at the unconference and really well-prepared one, and I think this will cause further discussions our side, and we are enlightened at least and made aware on a higher level of these issues and your pull requests and your waiting time. So thank you for doing the pull request, and thank you for preparing the presentation and making it an exciting one even for somebody who knows very little about TLS. So thank you, Daniel Lenske.
Great. Thanks very much. Bye.
And that also concludes this day of the MariaDB Unconference. See you again tomorrow morning at the set time, 9 in the morning. Thank you.